Padmakar? Okay, fine.
A very good morning, everyone. I welcome you all the day 2 of this virtual conference on future direction of subseasonal to seasonal prediction over South Asia, jointly organized by IITM and WWRP, WCRP, Subseasonal to Seasonal Prediction Project of WNO. We'll begin our third scientific session of this conference. We have 6 talks, each talk for 15 minutes, followed by 5-minute discussion. So if you have any queries, you can post your question in chat windows or raise your hand at the end of the talk. Now I request Professor Ajit Tati, former DGM IMD, and Professor Subhimal Ghosh from IIT Bombay to chair the session. Over to you, sir.
Am I audible and visible?
Yes. Yes, sir, you are.
Very good morning to the third session of this very important international conference on S-stress prediction. I can heartily welcome to the distinguished speakers and all the participants, and thank IITM and organizers for having given this opportunity to share this session along with.
Face is not visible. Slightly down, no, up. Yeah, still your face is not visible. Okay.
Is it okay now?
Still not. Yeah, now it is fine. Now
this is better.
Okay,
yes.
Thank you so much. I know. I'm not so savvy with the modern techniques. So anyway, thank you so much to the organizers for giving this opportunity. And I am really, I think, appreciate and acknowledge the gesture of IITM for having coincided this express workshop with the superannuation of Dr. Sahay, who had been pioneer in S2S initiative in South Asia. And in this session, we have got 6 talks. Each will be given 15 minutes to complete his presentation, to 5 minutes for question-answer session. And I request Subhimal to manage the session. Okay. We start with the first talk by Professor Yoniyama from Japan. He will be speaking on messages to S2S numerical modeling from the recent Maritime Continent Field of Sum campaign.
Okay.
Professor Yoniyama, floor is yours.
Yes, thank you for your introduction. From now, I share my slide. Can you see my slide and can you hear me?
Yes.
Okay. Okay, from now I will start. Thanks so much, and it is my great pleasure having this opportunity to deliver my talk in this conference. So I'd like to express my sincere thanks to the organizing committee for this arrangement. And also, I'd like to convey my words. Congratulations to Dr. Sahay for your accomplishment done for the past decades. I'm afraid many of you do not know me. I'm Kunio Yoniyama from Jamstech, Japan. And currently, I'm taking a role of the liaison to S2S for WMO WWRP since last October. Thus, I'm working with Dr. Sahay since then. But however, I'm not an expert of the numerical modeling. Rather, I'm an ocean-going scientist using research vessel and have organized several field campaigns. But most of those field campaigns have been dedicated to study the modern Diurnal situation. So although I'm afraid some of you may feel something strange about my talk title, message to S2S from Maritime Continent Field Campaign, but because I know this session is dedicated to the S2S focusing on South Asia, But I'd like to show some knowledge obtained through recent campaign that can be used for the SOS scale numerical model as well as South Asian studies. Okay. Of course, as I mentioned, the MJO is a key to connect today's session and me. While huge cloud ensemble directly impacts India and South Asian countries, its relation to the monsoon onset as well as the tropical cyclone are often reported, as well known. So, but just 10 years ago, we organized a field experiment to capture the features of the MJO convection initiation processes in the Central Indian Ocean by deploying many 4 ships, 2 aircraft, and island-based site, also the mooring system, and so on. And during 4 months period, from 2011 to October to the January 2012, we could capture the 3 MJO events. So far, over 200 papers have been published from this field campaign, and of course, this number is still increasing. But actually, today, I will not talk much about this campaign, except one thing. Currently studied the cases. If we look at the Hofmüller diagram of the IR and rainfall, you see, before initiation of the convection system over the Central Indian Ocean, cloud system moved westward like this. Okay. One previous study, his previous study mentioned that found that moisture air associated with. Oh, I'm sorry. I should point out. Okay. Moisture air associated with tropical cyclone developed over the South China Sea, arrived Sumatra area on December 11. Then convection with Diurnal cycle became very active. After that, cloud cluster developed over the Sumatra Island, moved westward with 2-day cycle. After several cloud clusters arrived over the Central Indian Ocean, MJO convection developed in late December, like this one. So this study suggests the relationship between the convection activity over Sumatra and MJO convection onset in the Central Indian Ocean. And this is just one example. And we do not now obtain robust idea on their relation. Okay. So very recently, my colleagues studied the behavior of Diurnal cycle rain over the Mediterranean continent and its impact onto the adjacent region using satellite-based high-resolution rainfall dataset we call GSMAP. And especially focusing on the impact to the synoptic disturbances. To examine Diurnal cycle rain, rain rate at each grid point is fitted to this form. Then you find strong and weak event using the mean value and 1 standard deviation like this. Okay. You can see the Diurnal cycle rain dominated along the west coast of this Sumatra Island like this one. For example, this shows the result of the composite or precipitation. Left panel shows the from 6 p.m. local time to the next noon. Left one shows the composite Diurnal precipitation. Okay, and the precipitation increase over the west coast of Sumatra in the evening, and a heavy rainfall region migrate offshore during the night time. Approximately about the 500 kilometers to the even 1,000 kilometers. Of course, such a features can be easily found when we show the Hofmüller diagram like this one. Develop the evening, then to propagate to the offshore. Then they study upscale effect of the strong dynamic event on synoptic scale disturbances, they calculated the eddy kinetic energy using this formula. I believe that you are very familiar with this formula. U prime and V prime are defined as the deviation from the 11. This time we choose 11 days running mean. Then this shows the composite for the leftmost panel shows the composite of the eddy kinetic energy at 850 hectopascal for the strong dynamic event. Generally, eddy kinetic energy is very higher over the open ocean. Here, rank 0 means the first day of a sequence of dynamic event, dynamic cycle event. Since the dynamic cycle is dominated and continues several days, we choose the first day as a lag 0 or day 0 as a reference point. Okay. If we look at the composite of the eddy kinetic energy temporal tendency, it is very clear to see the such extension of high eddy kinetic energy value to the west from the Sumatra Island. I think the much easier if we look at the this figure from the diagram. If we look at the composite of the time longitude section of the composite EKE, temporal tendency shows the clear westward migration of the, from the coastline from day 0 to for the coming several days, suggesting the influence of the dynamic cycle of the on the development of synoptic scale disturbances. To elucidate the impact of the dynamic cycle, the same composite was made with weak events. In the rightmost panel shows. However, you can easily see that a similar strong EKE generation is not found. The next slide shows the some statistical features of the strong dynamic event. The dynamic event appearance over Sumatra Island. Upper panel shows the strong dynamic event occur mostly frequently in October and November, and drastically decrease from December to January. And also, we check the such a behavior in terms of the MGO phase. Lower left panel shows the number of the appearance of the strong dynamic events in terms of the MGO phases. You can see the indicates the MGO. We can see the strong dynamic cycle event occur preferentially during MGO 2 and 3. Of course, the MGO convection is located in the Indian Ocean. In addition, this figure shows the strong dynamic event occurred in inactive phase of the MGO. Actually, indeed, numerous number of dynamic events occur even in the inactive phase of the MGO. So to investigate the impact of the on synoptic disturbance solely by the dynamic signal over the Sumatra during non-MGO and interaction between MGO and the dynamic signal through synoptic disturbances during the phase MGO phase 2 and 3, composites made for two cases. During the non-MGO, during the non-MGO cases in the right panel show the EKE first generated of the south of equator on day 0, then they spread both northward or southward. But however, the poleward propagation or migration are not so clear compared to the when we look at the MGO active phase during the phase 2 and phase 3. As you can see, there are twin strong disturbances straddling the equator develop of Sumatra and migrate forward and westward rapidly, like this one. Like this one. This apparent twin synoptic disturbances implies enhancement of the low speed wave response within the MJO. Namely, Diurnal events over Sumatra Island have impacted synoptic disturbances in the Eastern Indian Ocean, regardless to the MJO. However, the behavior is quite different depending on the MJO phases. And a strong impact on the South Asia can be found when the MJO is active in the Indian Ocean. So anyway, this study shows that I want to emphasize the Diurnal cycle of rain in the maritime continent affect synoptic disturbances over the Eastern Indian Ocean. And it may also affect the behavior of the MJO, which results in the impact to the weather climate system over the South Asia. Okay. So from now, I will show some results obtained by our recent field campaign over the maritime continent.
Dr. Yanama, you have 2 more minutes.
Okay.
Thank you.
I'm not sure whether you know or not, but currently we are conducting the field campaign, Years of the Maritime Continent, or YMC. It is designed to understand and improve our knowledge about the weather climate system of the maritime continent and its projection scale. And actually, YMC is consisted of many intensive observations with specific focuses, such as Diurnal cycle rain, Northern Julian oscillation, boreal summer interseasonal oscillation, and so on. Currently, at least 16 projects have been or will be taking place during 5 years. Some campaign plan, but unfortunately, some campaign plan this year or last year has postponed to next year due to the COVID-19. But fortunately, we conducted several field campaigns before the pandemic. Indeed, we just conducted the field campaign in the west coast of the Sumatra. This Sumatra campaign is dedicated to study the Diurnal cycle rain and the relationship to the Northern Julian oscillation. So we deploy our research vessel off the Sumatra Island, and we also deploy the land-based site over the Sumatra. Since we deploy the weather radar, we can capture the offshore propagation of the diurnally developed convection system during this campaign. You can easily confirm such behavior like this one. And actually, since our data set has already been to public, already open to the public, many numerical models are already used. This is one example. Meteorology Service in Singapore use our institute data, and they study the Diurnal cycle rain using their numerical model. As you can see, the left panel shows mean Diurnal cycle of rain at Bengkulu, but it shows difference of intensity and peak time. However, they notice that our institute sea surface temperature data shows higher than Liana's product by 1 degree Celsius or more. So they adopt institute sea surface temperature data instead of the Liana's product. Then the numerical model has been much improved like this one. We also notice such a temperature difference among analysis products. Here, monthly mean sea surface temperature for December 2017, when we conduct the campaign. While they show good agreement in the eastern part of the maritime continent or South China Sea, a large difference can be found off Sumatra west coast. By comparing sea surface temperature data obtained our research vessel using CTD measurement, we can confirm the some model present well for sea surface temperature, but some are not. Anyway, this result suggests that a precise sea surface temperature near the coast is crucial to simulate local convection system, and we need a reliable data set. Since the time is coming, so I will try to skip this one. But anyway, for the coming several slides, I want to show some candidate, because during this campaign, we deploy the several instruments to measure the sea surface temperature correctly and effectively. And for example, we now use the autonomous surface vehicle called Wave Glider. You can see we can deploy this system, and this in this system we can attach the not only surface meteorological sensor but also the GNS receiver to measure the water vapor. Okay. You can see just some example of our observation result. See, autonomous surface vehicle captures the surface meteorology very well. Compared to the Doppler radar, weather radar, we can confirm the abrupt changes of temperature, sea surface temperature, or humidity corresponding to the passing of the convective system. Also, the change of the wind is surely captured by this one. And also, as I mentioned, that we can right now measure the water vapor correctly. Okay. So currently, we are conducting many field campaigns. But during this campaign period, we developed and established the new observation tool to measure sea surface temperature very well. So we are now planning to deploy such a system over the maritime continent, based on the collaboration with the maritime continent countries. Okay, this is my current slide. I'm sorry, I quickly talked out, so maybe you do not understand what I meant. But several field campaigns we already conducted. And this study suggested the convection developed diurnally over the maritime continent might affect the synoptic-scale convective activity over the eastern Indian Ocean. It means that upscale effect or even maritime continent has some impact to the Indian Ocean study. And right now we are analyzing those data, so I think that you can use our knowledge and to improve the numerical model scale even over in the ocean. So due to the time, I will skip my slide to read anymore. That's it. Thank you so much.
Thank you, Dr. Yoneyama. We can take one or two quick questions before going to the next presentation. If anyone has questions, please raise your hand, or you can just ask, because it looks like there is no question. Thank you, Dr. Yoneyama. Now over to you, Dr. Tyagi, for the next presentation.
Well, Dr. Yoneyama has brought out the importance of field observations and upscaling of localized mesoscale diurnal variations influencing the MGOs. Well, I'm sure the importance of SST also has been highlighted. And now we go to the next speaker, who is known to Indian community, Mr. Lepo from Meteo France. He will be speaking about towards an operational use of equatorial wave theory applications to the onset and withdrawal of 2019 Indian summer monsoon. Over to you.
Good morning. Can you hear me?
Yes.
Yes.
Good morning, everybody. I'm very glad to be in Pune again. It's an honor for me to be invited with among these renowned scientists. So my background is mostly a forecaster. I have been a forecaster most of my career, and then I have trained the operational staff, forecasters, tropical forecasters. So I was in Pune 10 years ago in order to train the IMD forecasters in Pune and also in Kolkata. So I remember, I have good memories of Pune. So I'm doing a collaborative work in the domain of research to operations. So as a forecaster, I will just give a message to the forecasters and scientists and managers for operational rooms. So I work with Philippe Perrier within Météo France at the CNRM Philippe Perrier, mostly about the African monsoon, but also for French overseas territories. And for example, with our colleagues from La Réunion, the Regional Cyclone Center, we are experimenting the use of MGO and equatorial waves within the operational bulletins. And I have very nice work with Polish people, Piotr Flato, Maria Flato in California, and Beata Latos, who is a PhD student, and Darek Baranowski in Poland. And I also had this last year's nice exchange views with Shiromani Jayawardena in Sri Lanka about this new use of equatorial waves. So I'm going to show some slides who extracted from this great website. So you may know from Carl Schreck's North Carolina Institute for Climate Studies, and of course the NOAA CPC MGO page. I encourage the managers of the operational rooms, the forecasting departments, managers to give time to the shift workers in order to read the publications. It's important that the forecasters can have time to read what's published. And then I will tell that it's important that the scientists also have a look at what is operational forecasting. So, like 20 years ago, there were papers showing the role of intraseasonal variability within the like double monsoon onset and onset delays from Flat Maria and Piotr Flato and others. And then there were papers showing the complexity of all these waves with different scales affecting the monsoon onset. And recently, I find very important these papers that Andrew Robertson showed us papers from Vincent Moron and Andrew Robertson about the predictability types, and also Falco Jude about the predictability, potential predictability of the atmosphere. So this is very important for me. So I chose the year 2019 because I saw in your summaries, in IMD summaries and in the newspapers that it was a 1 week delay that year. So it was interesting to have a look at it. But it will not be a complete case study. It's just an illustration of the message I want to give to forecasters. It's not a complete case study. So I'm starting with the low frequency anomaly, we can call a background flow, which is an important piece of the puzzle about all these ingredients. So this year there was the remnant of a weak El Nino, as you can see the SST index, and to the right you can see the VP200 analysis for May, June, July. There was a remnant of a subsidence area over Asia. With above average cyclonic in stream function, cyclonic field, which means more westerly disturbances for northwest India and Pakistan at that time. So this was the remnant of El Nino situation. You probably know this chart from Carl Schreck. This is the low frequency anomaly filtered by Carl Schreck in purple isolines. So to the left, it's the precipitable water. So it's supposed to be the prediction from the 21st of May that year. You can see on the left column, it's the observed, and on the right and to the right, it's the prediction. So you can see the isolines, the showing a dry anomaly over India during this period, provided by the low frequency. And to the right, it's the component of the wind 850 zonal component, and also there was a clear easterly anomaly provided by the low frequency, so which goes against the main climatological westerly flow. The RMM index. This is an extract from Climate Prediction Center bulletin at that time. There was a continued eastward propagation of the MGO. There was a robust MGO predicted to enter the Indian Ocean, but weakening while over the Indian Ocean. This was the prediction from the 21st of May. This is the bulletin from the CPC, Global Tropics Hazards and Benefits Outlook, which is a great product for us. And you can see I zoomed over India. You can see the dry anomaly and a heat wave probability for week 1 and week 2 still issued on the 21st of May. Just one verifying analysis. You can see on the left, it's to the left, it's the prediction, and to the right, it's the observed analysis of the OLR and filtered with MGO by Carl Schreck. You can see that the forecast was not a good forecast of OLR, because already at week 2, the observed was much more active in the equatorial region than when it was expected. So even if the RMM was robust, the prediction of OLR was not perfect at all. So now I'm going to show some slides with a new tool, spectral weather tool, which extends Cameron's Beccario's Null School project. So it's a tool developed by a team led by Piotr Flateau at Scripps Institution of Oceanography, with different people around the world. And it's about decomposing the total field into, and meteorological and oceanic fields into equatorial waves, as you can see to the right. So this tool, if you have questions about this tool, it will be presented by Beata Latos in April during the European Geophysical Union Assembly. So I encourage you to listen to this. So these are screenshots for I selected one field, which is the vertically integrated water vapor flux. You can see from late May to mid-June. And as you can see to the left, the climatical westerly flow was disrupted by some features over the Western Indian Ocean at that time. And it's only on the 5th of June that the westerly flow reached Sri Lanka, but not Kerala yet. Kerala was still under northeasterly winds and moisture transport. And from the 8th of June, the date the monsoon was declared, you can see what looks like an onset vortex, which became very severe cyclonic storm Vayu, which moved north along the coast. And you can see this nice westerly flow reaching India, but late compared to the normal date, which is the 1st of June. So this is the same, it's just seen through the animation you can have on the website. It's a public website, spectralweather.com. This is early June, and this is later in June. You can see this nice stream flow, monsoonal flow reaching India. So that was the total field. So what's the contribution? What was the contribution from the MGO to the U850? I selected this field, still in Carl Schreck's chart, in what I can call traditional view with Carl Schreck's website. You can see this dashed line, which are the easterly anomaly provided by the MGO in black. So there was a clear easterly anomaly that added to the background anomaly. And then the westerly, in red, the westerly anomaly reached India very late in the season. Same scene through spectral weather website. You can see the easterly anomaly provided by the MGO and the westerly burst arriving late. Same here. The contribution from equatorial Rossby, there was a nice westerly burst due to an equatorial Rossby and a horizontal wind shear, which helped trigger this vortex, which led to the cyclonic storm. And then there was, from mid-June, there was a long band of westerlies from the Arabian Sea towards Japan. This reminds us the second component of the BSISO that Frédéric Vittard told us about yesterday. So when we are used to it, we recognize the equatorial Rossby-like component of the BSISO2. I will not show the index here. So the same seen through the tool, with some westerly burst and two symmetric vortices provided by the equatorial Rossby, and still some northeasterly component provided by the equatorial Rossby over western India, so preventing the onset of the monsoon when added to the MGO and to the background flow. And then from the 8th of June, there was a nice southwesterly flow reaching India, provided a contribution to a southwesterly flow provided by the equatorial Rossby. This is as seen with the tool. You can see the very big change in the contribution from equatorial Rossby in a few days. Finally, the Kelvin wave contribution on the 2nd of June, so the climatical dates, there was an easterly contribution over Western Indian Ocean, and then it changed to westerly contribution, but we clearly see a link with an equatorial extratropical feature in the southern hemisphere, which reached Sri Lanka and Kerala on the 7th of June. So there was a contribution to westerlies from a Kelvin wave, and it seems to be linked to some feature in the southern hemisphere. The same seen through the website. And finally, there was a big mixed Rossby gravity vortex provided. The vortex streamlines provided by the MRG on the 9th of June, and it may have helped to trigger this onset vortex and the deepening of the tropical feature. So now withdrawal in a few minutes. So the withdrawal was the latest in the recorded history. The background was a record positive IOD associated to a very strong anomaly of divergence over most of India, which favors, of course, the late activity of the monsoon. There was also a very strong precipitable water anomaly, so moisture anomaly over northern India linked to this VP200 field. And in flow in 850 streamlines, there was a low anomalous low circulation, which favors the still active monsoon trough late in the season. This is a product from CNRM. This is provided by the low frequency anomaly, which is above 120 days. So here is the feeding of moisture still in late September. There was still a very strong, the red is the moisture field, the total column water vapor, and the green is dry air mass. So you can see this moisture feeding into northern India still in late September. The same seen through different dates. A big change in the flows, stream flow and the moisture content. And this is the date of the withdrawal on the 8th of October. You can see the drastic change in the stream flow. Contribution from MGO to VP anomaly was starting from the 8th of October. There was the dry phase of the MGO brought subsidence over the region, which helped to start the withdrawal. You can see the flow provided by the MGO, which really looks like the total flow. So the MGO was a strong ingredient in starting the withdrawal.
Sorry to interrupt. You have 2 more minutes.
Yes. Okay. So the total precipitable water, there was a strong wet anomaly, and then later, starting from the 8th of October, a dry anomaly, a dry phase of the equatorial Rossby that you can find here on Karl Schreck's Hofmodel diagram. So the dry anomaly helped the MGO, which helped the low to install the withdrawal, and you can see the shift of the stream flow and moisture field provided by the equatorial Rossby. Okay, so as a summary, the delayed onset, it was not a total, a complete case study. It was just to illustrate, but the delayed onset and withdrawal could be due to a superposition of ingredients that are part of the seamless time scale from low frequency to the MRG. So my message is that, as we can see through the outlooks from CPC, NOAA CPCs every week, my idea that there is place for human meteorologists into this S2S timescales in order to bring out the best of numerical models, in order to accompany the numerical models, to elaborate, to synthesize, to communicate useful information to users, both in technical terms, but also for user-oriented bulletins at this range. So I encourage some forecasters to get motivated into this kind of new expertise. So the idea, I don't know if it has been done yet in your region, it would be to set up like a weekly discussion, like the CPC's discussion or the BOM discussion, a weekly discussion over South India, South Asia, I would say, among international mixed pool of operational staff, atmosphere scientists, but also ocean scientists. It's very important to have ocean scientists sharing knowledge about the current situation. So my last slide would be, as a forecaster, I have been a forecaster when I didn't know about these waves at all, even if maybe I had learned a bit at school. But now that I understand the role of these waves, it's a bit like a puppet theater. You know, when I was a child, I only saw the puppets, and now I can see who is pulling the strings behind the puppets. So the waves and the MGO and the low frequency and the SST and so on are all these ingredients pulling the strings of what we see on the operational. This is a traditional chart from the BOM yesterday with streamlines. So you can see the streamlines and the lows, but you can also see on the right what's behind. It's these waves, and this is an experimental graphical analysis and forecasting chart that we're trying to make for beginners, especially to train beginners about the role of the chart. Thank you.
Thank you, Thierry, for such a thought-provoking presentation on the role of equatorial wave in several monsoon characteristics and how to take it to S2S. So we can take a few questions. Yes, I can see Professor V.B. Rao. Professor V.B. Rao, please. You are muted, Professor V.B. Rao. Professor Rao, you have raised your hand, but you are muted.
Okay, can I talk now, please?
Yes, please.
Yeah, so I want to ask what created these equatorial waves, like the mixed Rossby wave, Kelvin wave, and the Rossby wave. As I know, normally the equatorial heat sources and sinks generate these waves. So I want to ask this particular question, please.
I'm not sure I have understood all the questions. Is what's the physical processes behind these waves?
Yeah, what created these waves? Normally, the heat sources and sinks over the equator create these waves.
Yes.
So how these waves are created? Because that is the basic question to understand the onset and withdrawal predictions.
Well, I'm not a scientist, but I know that, for example, during the MGO, in the MGO envelope, the heat source create a Kelvin wave moving Kelvin and equatorial waves. So when the MGO is, for example, like these days over the maritime continent, some equatorial Rossby waves. And also, Professor Yoneyama showed us that the diurnal cycle over Sumatra may be helped by equatorial wave moisture, help trigger this like double vortices. So this is at first produced by the MGO envelope, and then when the MGO envelope moves over the Pacific Ocean, then we still have some waves crossing, turning around the globe and coming from the west, from the old envelope. So there are always some waves around.
Okay, thank you very much.
Yeah.
Thank you, Professor Rao. Any more questions? Okay, if there is no question, thank you, Thierry. And over to you, Dr. Tyagi, for announcement of the next presentation.
Before I announce invite next speaker, I'll request organizers to take note of suggestions made by therefore about having, I think, discussions amongst the forecasters and atmospheric and ocean scientists about extended range operationalization of extended range predictions. This could be one of the recommendations of the workshop. And now I invite Dr. Francisco from Spain, who will be speaking about the forecast quality assessment for climate services based on S2S predictions. It's very important from the user perspective. So, Dr. Francisco, floor is yours.
I hope the sound is okay. Very good, thank you. So my presentation is going to be very different to the previous two, focusing on slightly orthogonal aspect, which is climate prediction on subseasonal to seasonal timescales that were already mentioned in several of the presentations yesterday. So I'll focus mainly on the role of forecast quality and how this is relevant for the development of climate services in an operational context. There are some barriers that are preventing users to use climate forecasts. There is an illustration here of that there is not comprehensive. So some of these limitations come from the lack of awareness of the users. There are difficulties in the interpretation, and there are, among many other things, lack of expert synthesis of the many sources of information. Some solutions have been proposed, which are basically consisting in the conversion of the climate forecasts produced by a large number of institutions around the world into information that can be integrated in decision making. And this is basically something that climate services is trying to do in the context of the requirements formulated by a number of users and using a methodology that consists in co-production and co-design of this climate information. What I'm going to say in this presentation is relevant not just to India and the South Asian region, but all over the world, because most of the climate forecasts are global in scope. Climate Services has identified a number of focus requirements that consists in formulating targeted products that need to be widely available for a number of sectors. The need to understand how the information can be used and integrated in the users' operations and activities. The clarification of what is the added value of these new climate information coming from climate predictions. Also, the need to reduce uncertainties and increase the skill of the current climate forecasts to attract the attention of the users. And among many other things, also formulating predictions that are coherent with the stories that are being formulated in terms of climate change projections in the long term. There has been in many different contexts formulated the need for also finer spatial resolutions using downscaling, even going down to urban scales, which is something easier said than done, because there are many other challenges associated with the formulation of this local information. In any case, focus quality is inseparable from focus products. And this, which has been very well known in weather forecasting for a very long time, is not an idea that is pervasive all over in the climate prediction worlds. Users often look for the climate forecasts online, and these are examples of the seasonal forecasts for the past, taken from the Lead Center in Korea. Which is gathering information from many different seasonal forecast systems and put them in graphical form as they appear here. However, the information that is formulated and provided by the Lead Center, which is very valuable, lacks some elements. For instance, it doesn't provide information about the quality assurance, or at least the quality assurance methodology, the traceability of how these maps were produced, and some guidance for the interpretation. So how do we go about the provision of information that is more relevant to the users and that considers the challenges that I mentioned previously? One of the aspects, and I'll list a number of aspects in the following slides that I'll try to summarize at the end, is the consideration of observational uncertainty, and this is relevant to users, and this is something that I'll try to illustrate in the next two slides. Here you can see an illustration, some maps that are showing the trends in 10-meter wind speed from different reanalyses. Reanalyses are not the truth; they are not observations. And it's still they even disagree among themselves, and this is what we can see in the panel F below, where we can see where there is a agreement in those trends around the world, and there is not that much agreement. Sometimes because there is not a trend, some other times because the reanalysis disagree. It's quite interesting to see that there is some agreement in the Indian Peninsula, and having agreements among the reanalysis doesn't really mean that those reanalyses are providing useful information. And I'll try to illustrate how the selection of specific data sets as a reference for the verification of the focus products can lead to different results. And this is what is shown in this slide, where I'm verifying the ECMWF System 5 seasonal forecasts over different regions in the around the world that appear at the top right part of my slide, where I use the IPCC regions as defined for the 6th assessment report. And if you look at the results that are encompassed here in the red oval, at the top, you can see the skill measured by the correlation of the seasonal forecasts, where I'm using always the same seasonal forecasts in the verification. And below, you can see the results of the biases of the mean wind speed over the South Asian region, which is the region that appears here in these parts. We have in the slide as well results for 3 different reanalyses in dark blue to light blue, and 2 observational data sets, GSOT and HAD ISD, which are the lighter box and whisker colors that appear in the 2 panels. And what we can see is that in terms of biases in the lower part of the panel, we see that the against the observations, against the 2 observational data sets, the biases are positive, and they are actually fairly large against the 3 different reanalyses that tend to agree in terms of trends and also in terms of climatology over South India. The forecasts have a 0 bias, or they have a close to 0 bias. The forecasts have a higher skill compared to the reanalysis than compared to the in situ observations. So most often we provide the focus quality information comparing with observation with reanalysis, which in a case like this one is going to give us an over-optimistic measure of the focus quality than when we measure it against the observations, which is what is actually relevant to the users, because the users are used to look into the observations, which is basically what they employ in the calibration and in their decision making on a daily basis. There is a very nice paper by Chris Farrow where he says that failing to account for the effects of the observational error when deciding between 2 focus systems, or when deciding about how to use a climate focus system, will lead to the wrong choice and a high opportunity costs. So here we have an example of how users can be badly affected by observational errors. Also in terms of climate forecasts, in particular in terms of subseasonal forecasts, what we find is a lack of standards and guidance for the users. This is a slide that we could see yesterday in the Subseasonal-to-Seasonal project presentations, where we can see the different systems that contribute to the S2S project here in the vertical. And we see that there is a plethora of systems that have very different ways of initializing both the forecasts in green and the hindcasts. And that raises the question of how do we formulate the products and how do we formulate the climatological estimates that we are using to, for instance, define the anomalies that are provided to the users later on. So, for instance, if we are going to provide a subseasonal forecast for the 4th of April, we might ask ourselves the question of what is the climatological reference period that is going to be used to formulate the anomalies. We could use just a weekly climatology for all the forecasts, using all the forecasts that are starting on the 4th of April. We could use the full month of April, or we could use a monthly running window around the 4th of April. And this choice has a very important consequences in terms of the focus quality that is provided to the users. And this is what I try to illustrate here, where by using the continuous ranked probability skill score and predictions of 2-meter temperature, using one of the systems that I mentioned before from the S2S project, we can see that the estimates of the skill that is in these plots here, we can see if we focus on the left column that using always the same forecasts, we have very widely different estimates of the focus quality depending on whether we use the month of April for as a reference for the climatology, whether we use only a week for the same start date that is being used for the forecast, or whether we use a monthly running window. So we published some recommendations for climate forecasters on how to set some standards for the formulation of these products. And there are many other aspects that have to be taken into account, such as focus timeliness, how the systems are updated, and how to build a multimodal, which is far from trivial. All this is very important information, the formulation of standards for the release of quality control information about any of these systems, subseasonal or seasonal. In the Copernicus Climate Change Service, which is the European Commission's service for climate change in Europe, we develop the evaluation and quality control function for the assessment of the data sets, but also for the assessment of the whole service. And somehow we look at this as the same kind of approach that is being used in a drug leaflet, where there is not just information about what the drug is made of, but also how to use it, what are the pros and cons, and what are the secondary effects. So somehow the focus quality assessment is one of the aspects that should be included in the quality control of climate information, and in particular of climate information that has been produced with climate forecasts. Other aspects that are relevant to the users is the formulation of user indicators, and I'll skip this slide for in the interest of time. But basically, is just illustrating that somehow one can produce also forecasts and verify those forecasts for indicators that are relevant to those users, that going beyond what the meteorological variables can say. The interpretation of the information and the communication of this information also requires, for instance, examples and guidance for the users. And we have been using gamification that we have published in a BAMS paper recently, where we use the mobile phone application to illustrate what is the potential value of the information for, in our case, wind forecasters around the world. This is my last but one slide. somehow the users are confronted with the emergence of a plethora of climate-focused systems that can be used to formulate the climate information. The multimodal approach has been used to synthesize this information. This is not the end of the story. There is a lot of additional explanation that has to be provided when making multimodal products, and in particular, for instance, there are different ways of formulating a multimodal forecast, as we can see in the right-hand side plot, where different options made to build a multimodal lead to different results in terms of the continuous ranked probability skill score, in this particular case for 2-meter temperature during the boreal winter. This is my last slide. I just wanted to raise the need to take into account a list of relevant elements that need to be considered by climate forecasters to have an efficient interaction with the users and to take advantage of the feedback that the users will throw at us. One of them is the need to take into account the observational uncertainty, the definition of standard procedures that are transparent enough for the users to know what they are handling, the need for traceability and quality control, the formulation of user indicators that are also validated in the same way as we verify the meteorological and climatological variables, what we denominate essential climate variables. The importance of the interpretation and the communication of these forecasts in an understandable manner for the users, and the huge gap that we have in the synthesis of the huge number of sources of climate-focused information that basically needs to be integrated into a single entry point for the user, so that the user doesn't need to be confronted with the use and the access to many different data sources. And I'll leave it there. Thank you very much again for the organizers to give me this opportunity to talk to all of you.
Thank you, Dr. Francisco, for such a nice and informative presentation on the importance of quality assessment of S2S in making them usable for climate services. Now it's open for questions. I can see Professor V.B. Rao has a question. Professor Rao?
Yes. I have a comment rather than a question. It is, when you take into consideration the observations and the model results, you should be very careful. The observations have the advantage of lack of model errors, while in the case of model, it's entirely highly model dependent. So one should take into consideration both, I think. Although you mentioned observational uncertainty in regions where observations we have really some observations, then you should compare with the model, because model is always highly model dependent. So in the case of observations, there is no physical consistency, while in the case of model, although there is physical consistency, there are highly model dependent. That's my comment, please. And another comment is about the role of climate change. In the case of S2S predictions, and one should take into consideration, I think you very correctly mentioned the role of climate change. Thank you very much.
Thanks very much for your comments.
Dr. Francisco, I think we have lost Dr. Francisco. Yeah, we have lost him. So, yeah, over to you, Dr. Tyagi, for the announcement of next presentation.
Yeah, we have a next presentation from Dr. Mitra, who is the director of NCMR WF, and he'll be talking about seamless prediction from days to the seasons. So overlapping the S2S, so it will be, I'm sure, give a new perspective for end-to-end forecasting system. Over to you, Dr. Mitra.
Good morning, Dr. Tyagi and everybody there. So first of all, am I audible?
Yes, thank you.
Good morning, everybody. Thanks to IITM for giving me this opportunity to present some of the works of NCRWF. And I take this opportunity to congratulate Dr. Sahai, who has contributed immensely to this extended range prediction. And I wish him all the best in future. So I'm sharing my screen. Is it, can you see it?
Yes, please go ahead.
Yeah, so I'll be talking about the seamless modeling system we have put in place at NCRWF. So we do a lot of work at NCRWF, but I will be restricting myself to only the coupled modeling part. And of course, I will describe very briefly the seamless system which we have. So today morning, we have heard from GEMSTEC the utilization usefulness of field campaign. So there are a lot of field campaign which happens from time to time. And IITM also collects a lot of observation, and we have seen this Indo-UK, Indo-US field campaign. So these field campaigns are very useful for model development. And that's where this seamless modeling system comes in. So this is the outline of my talk. Very briefly, I will touch upon the seamless modeling system. And I will talk slightly more about the multi-week S2S prediction system and what's our plan. So as we know that NCRWF is engaged mostly in data assimilation and developing application related to this modeling system. And what we have, the different data assimilation system at NCRWF related to the seamless modeling system is the hybrid Ensemble global data assimilation system, which has 22 members and 12 kilometers. Then we have this regional data assimilation system, then land surface model Joules and its data assimilation system. And very recently in 2018, we have put in place the NEMO global ocean model and data assimilation system. And of course, we have another data assimilation system catering to the IMD, IITM's GFS and WRF. And among the various models, which is part of the seamless modeling system, we have the global 12-kilometer model and global 12-kilometer ensemble model, then regional 4-kilometer ensemble forecast system, and very recently the couple model, which is being run daily up to 2 weeks and once a week for 4 weeks. And very recently from 2020, we also do the seasonal forecasting for every once in a month for next 5 months. So this is briefly all the models what I was talking about. So the same modeling system, the same dynamical core, which is used starting from very fine scale 330 meter model to 1.5 kilometer model, 4 kilometer covering India, then 12 kilometer covering the whole globe. And as I said, the advantage of this seamless modeling system is the model development cycle is very fast here, and all the field campaign data can be used here, starting from very small scale. And of course, the MGO purpose, what today morning GEMSTEC speaker introduced. So all this field campaign data can be used for model validation. And that's one of the advantage of this seamless modeling system. So here you can see what I showed in previous slide. On the top left-hand side, you have this 330 meter model, which is mainly used for fog prediction for Delhi. And then we have 1.5 kilometer model. The 330 model is nested within this 1.5 kilometer model for visibility purpose. Then this is the 4 kilometer model, which is very good in capturing the mesoscale convective system. So what you see here is we had this Agra wind gust thunderstorm activity where a lot of people lost life. So this model captures that. And of course, then we have this 4 kilometer ensemble system. And this is the global model. And these two are from the coupled model. And another very important tool what we have is related to the data assimilation, that you can study the impact of different kind of satellite data. So very recently, we have introduced the LU's data. and you can study this different in situ and satellite data, and it's very useful for planning that where we should invest in observations. And coming to the ensemble prediction system, MOES has two very high resolution global ensemble prediction system, which is at 12 kilometers. So combinedly, there are 42 members, and the unified model has 23 members, which is at 12 kilometers. And all this data is available in TIGI portal of ECMWF. Anybody can download this data. And this ensemble forecast system is very useful because it gives the probabilistic forecast of, we have seen tropical cyclone, but for any severe weather also it can be used. And the 4-kilometer model also very useful for severe weather, the ensemble prediction system. And we have seen how this ensemble prediction system helps in severe weather. This is an example of the Kerala heavy rainfall in 2008 in August. So this is the observed rainfall. And what you can see, the probability of exceeding 6.5, 11.5 centimeter per day, and the day 4 forecast. So the model was indicating that 4 days in advance that over Kerala, that's going to be very heavy rainfall. Now coming to this coupled modeling system, which is the theme of today's talk in this S2S prediction, we have put in place the atmosphere, Jules land surface, NEMO ocean model, and Las Alamos laboratory sea ice model. And what I said earlier, the global data assimilation system is being run in real time daily, and every day the coupled model is being run up to 15 days. This is very useful in cyclone season. It gives the tropical cyclone hit potential. Then once a week we have this extended range multi-week forecast. Then once a month seasonal forecast. And very recently we are in the process of implementing a high resolution regional coupled model covering Bay of Bengal and part of Arabian Sea, which will be very useful for process studies, understanding the severe weather, and ultimately we'll try to make it operational for cyclone and other monsoon lows and depression forecasting. So the ocean assimilation system is very similar to what ECMWF has. It's a global NEMO VAR system, and it can assimilate various kind of in situ and satellite observation, and it uses the global NEMO model, and it uses all the data in 24 hours, and once a day the data assimilation is done. This is mainly to initialize the ocean model, part of this coupled model, and these are the list of all observation it can assimilate. This is one of the best ocean data assimilation system anywhere in the world. And we have compared this ocean analysis with the Rama buoy. They compare very well. And our Indian satellite Saral Altica, which was launched in 2000 and 2010 onwards. So we have specifically done the impact studies. What's the impact of this Altica data? And we have compared the quality of this Saral Altica with JSON 2. So the quality was very good. And we have seen the Indian Ocean biases are reduced when you include this sea level anomaly from the Saral Altica data. And very recently, our MOES Institute NIOT has put a lot of radars, coastal radars, which gives you coastal current. And this is actually becoming very useful to validate the ocean model. And there are these are very high resolution observations. So we are seeing the strength and weakness of the ocean model. So this is helping us in improving the model. We also compare the ocean analysis, which is very crucial for this S2S prediction. So this is an example. The top row is the MLD from Argo data. You can see it. And the middle row is from the GODAS, NCEP GODAS. So we downloaded this data. So for different season, pre-monsoon and monsoon, post-monsoon and winter. So what we see, the GODAS of NCEP has big biases compared to the Argo data for the MLD. We have seen other field, but I'm just putting this slide because it's very important to prescribe the ocean initial condition very realistically. And another thing of this coupled model I would like to show here, that there was a tropical cyclone Fani, and it hit on around 1st May. And this is the tropical cyclone hit potential, which comes from the coupled model. And you can see these are day 1, 2, and day 15 forecast. So if you remember, the cyclone was formed here somewhere in the South Bay, then it moved along the coast and ultimately crossed Odisha coast. So this is mainly because of the current and the tropical cyclone heat potential there that the cyclone was maintained. And this ocean coupled system could maintain that tropical cyclone heat potential 15 days in advance. And we have seen other oceanic feature, for example, the salinity propagation in the analysis, and these are day 5 and day 9 forecast. So the salt which propagates northward, and the Arabian Sea high saline water mixes with the Bay of Bengal is compares well with the observation. And another feature is the week 1 and week 2 saline water movement. If you see the top row is the analysis, and these are the mean week 1 and week 2 forecast for the whole monsoon season. So what you see, the high saline water entering the Bay of Bengal is maintained very well in the model. And now coming to the extended range multi-week forecast, this is the setup. We have relatively slightly coarse model compared to the IITM. It's 60 kilometer atmosphere, and there are 85 level resolving the stratosphere. It's one of the good thing of the model. But the ocean model is very high resolution in the vertical. So we have 1 meter near the surface. So the air-sea interaction is resolved very well. And from 2018, this real-time extended prediction started. And we have seen the mean model biases in week 1, 2, 3, 4. So there are equatorial biases because the northward rainfall belt doesn't move properly. But over land, the biases are not so big, and it's usable. And we have seen the skill from the hindcast. So this is about 23 years of hindcast data. So these are the skill of rainfall anomaly in week 1, week 2, week 3, and week 4. So the week 2 skill is very good. That's what we are expecting in the subseasonal prediction. The week 2, if it is usable or not. And many times we have seen the week 3 also is very good. And we have seen the model captures very well the transition from active to break and break to active. These are some of the examples where active monsoon was captured very well. This is the break condition, was predicted 4 weeks in advance. And we have seen some cyclone also. It's captured almost 3 weeks in advance, this cyclone Bulbul. The model was indicating that there will be highly convective condition and the anomalous wind 3 weeks in advance. And the monsoon onset also comes very good in week 3 and sometimes week 4. In this case, it was week 4. It was indicating the rainfall belt is moving over Kerala. And we have seen the temperature anomaly, T max and T mean, and we have compared with the NCEP system. So this is the observed, the left column you can see. So the top row is for the NCEP CFS system at T126. It has a bias, warm bias. But this is the our coupled system. So the northern part is below normal, and the peninsular India was above normal. And the model could capture very well a similar thing in the T mean. And going to the seasonal prediction, we have seen this model is good compared to many other models. So, for example, this is the Metopis Unified Glossified Seasonal Forecast System. It actually is better than the multimodal ensemble mean. This is, of course, for extended monsoon region, which covers whole continent of India, then part of Arabian Sea, the offshore rainfall, and part of Bay of Bengal. So if we take extended monsoon area, the scale is very good. And we have compared the model scale in the seasonal scale with ECMWF, almost comparable scale there in terms of model biases. And we
Dr.
started
Mittal,
with, yeah.
Sorry to interrupt, we have 2 more minutes.
Yeah. So these are a few slides I will conclude here. So the seasonal forecast, we started from 2020. And these are some of the example of the anomaly forecast 2020. We gave a normal to above normal rainfall for the monsoon. And in terms of tercile probability, it was showing a highly probable positive anomaly rainfall for 2020. These are the bias corrected rainfall, percentage departure. And we have again compared the anomaly correlation of the seasonal with ECMWF. So they are almost comparable in terms of the scale. And we saw almost 70% of the cases of the interannual sign of the model in terms of anomaly was predicted well. This model is also capable of doing the polar forecast. So we do 15 days polar sea ice forecast, extended range forecast, And this is very useful for our MOES institutes operation in the polar region where these ships, etc. move. So I will conclude here that a seamless unified modeling system has been put in place. So we have starting from very small scale, 330 meter up to a season. And what we are planning is by next year, we'll have a coupled NWP at 10 kilometer atmosphere, and ocean maybe 25 kilometers same. But the S2S prediction, the extended range prediction, we want to go to slightly higher resolution at 35 kilometer atmosphere. Then we are working on a regional coupled model, as I said, 1.5 kilometer. And the coupled data assimilation, weekly coupled data assimilation also we are working, which will be implemented by next year. Thank you.
Thank you very much, Dr. Mitra, for highlighting the exceptional work done by NCMRWF. Now it's open to questions. If anyone has any question. Yes, Professor Rao, you have raised your hand.
Yeah, I'm sorry for making so many comments. But anyway, first of all, I congratulate the extraordinary work the NCMRWF is doing. It's very, very important, and really it is excellent. And my one suggestion is, if the model improves the forecast, why it improves the forecast by means of some sort of a physical explanation. What I am suggesting is to do some sort of a research work, why the model has improved. Or in other words, if the previous model doesn't predict properly and the new model with more resolution, more physical parameters improves, some sort of a research work, why it has improved. That will be very useful and very important, because the actual physical process are very important by means of what you call the forecast. Thank you very much. Excellent, really excellent work NCMRW is doing. Congratulations.
Thank you. Thank you.
Dr. Mitra, are you going to respond? I'm sure.
Basically, Dr. Rao, he gave some comments. So what I presented is the seamless modeling system, which is very unique. We have done in collaboration with the AUM consortium. But what Professor Rao said, a lot of other research work, diagnostic that we are doing, and I did not present here. But it's very important to simultaneously do the diagnosis and keep on doing the improvement, particularly monsoon. So we do those things. Thank you very much.
Thank you.
Thank you, Dr. Mitra, and thank you, Professor Rao. Any more questions? I don't think there is no question. Thank you, Dr. Mitra, and over to you, Dr. Tyagi, for the announcement of next presentation.
Next presentation is by Dr. Parthasarathy Mukhopadhyay from IITM. He has been closely involved in various activities from weather to the extended range predictions. So we'll be speaking on lessons learned from the weather scale forecast to improve the fidelity of S2S. Here again, the linkages of the weather scale to the S2S is, I'm sure he'll be highlighting. So over to you, Partha.
Yes, sir. Thank you, sir. Good morning. Good morning to all of you, and good afternoon to friends from Japan and Singapore and so on. So am I audible and this slides?
Yes, you are good. Yeah, excellent.
Okay. So as good morning to chairs, Dr. Subimal and Tyagi. And thanks to organizer for giving the opportunity. And what I thought is that although I am mainly engaged with GFS medium range forecast, but there is no point in beating my drums here on GFS. So to do justice with the theme of the workshop, I suggested this topic where I'll be leapfrogging between the short range, medium range and the extended range, and what we have learned from short range, medium range to which can do something for improving the fidelity of S2S. So here are all the collaborators from IITM. This will be the brief outline of the talk. And so I always show these slides because this is one paper I think which all students, everyone should read.
Your slides are not moving, Partha.
No? One minute. Is it visible now?
Please, on
Yes.
slide.
Yes.
Not in slideshow mode.
Okay.
I can see slide 3, but it's not on slideshow mode.
Now, is it in
No,
the
still,
slideshow?
no, still not.
Again, reshare entire screen and then only it will be.
No, sometimes Teams has that problem. In that case, you have to share the entire screen, then it works. I have seen that.
So,
If you share your entire screen, if you stop sharing and then start sharing
Okay.
your entire screen, then will work. Specific
Let me-
applications sometimes Teams create this problem.
give me a minute. So I'm sharing once again.
The entire screen, if you share, then it will work. The full screen.
Okay, this time. Let me open. Is it visible now?
No, you have not opened, I think.
Yes, you have not opened the presentation file.
1 minute.
Sir, shall we share the screen from here?
Can you do that?
Yes, sure.
1 minute. So let me close the tray. Okay, please share it. Yeah, go to the third slide, maybe. Yeah, okay. Yeah, thank you. So what I was trying to tell is that in this slide, I mean, this is one of the very, major, I think, paper, I should say, in the which documents all the features of, the NWP, and it shows very clearly the linkages between the, short, medium, and the extended and beyond. And it also shows that how the model complexity grows and where we need the coupling and where we can still live without coupling and so on, and what is the role of model resolution and so on. I cannot go into the detail of what is written in the paper, but it also emphasizes the representation of physical process in parameters, which is important for all the across the scale. Can you go to the next slide? Yeah. So this slide, why I kept is because this gives a glimpse of what all forecastings are being done presently in IITM, and we are in this domain where we do the medium range and extended range and seasonal, but there are also a huge activity going on which truly runs from minutes to what is called to season or to climate. But this regional model basically depends heavily on the initial and boundary conditions from the large scale model. So what is important is the fidelity of these models should be very good, because that will basically decide also the simulation and skill of this forecast. And below I showed a figure from Diurnal 2015, which basically shows that when we go from short range or medium range 10 days to weeks to months, then there are slowly varying factors, boundary forces like land surface and so on, that becomes important. And yesterday we heard Secretary Sir is mentioning that all over India there will be a high density data set for soil moisture, which will be greatly helping, I think, these extended range forecasting initiatives. Next slide, can you go? Yeah, so this is actually why I showed this, because in WMO in 2015 this book came, and where they said actually minutes to months. That was the kind of the slogan that started in 2015 to 2020, and actually IITM has almost reached there. We have achieved, and actually IITM is going beyond. I mean, there is one. So one gap was filled by Sahaji and his group, which was not there actually. It's east to west. Another gap is decadal predictability that also will be filled very soon by Dr. Seelan and others. Can you go to the next? Yeah, so this is actually from a paper of one of my students in 2016, where we have shown that this is using the TIGI forecast, okay, from the difference between ECMWF and INCEP, the difference of rainfall precipitation bias, and you can see that the error actually starts growing in the equatorial region, and by the time we go to the 10-day forecast, of course there is a difference between ECM and INCEP. But nevertheless, you can see that the error is growing systematically in the equatorial belt, not so much in other places. So this is the region where generically the error grows, whether it is in the day scale or within the week scale. I'll come very subsequently. Can you go to the next? Yeah, so this is the system which we are now running. That what Dr. Mitra was telling. This is actually been made operational to IMD in 2018, which is this is the GEFS, 12 kilometer, presently the highest global resolutions in the globe, 12 kilometer with 21 ensemble. But all data are being now available in the TIGI archive, and this is the control systems. Go to the next. Yeah. So so far so good. I mean, people have already appreciated all the good things. Subsequently I will also try to bring out what are the limitations. So here it's a good story, that what we showed here is that when we were running a T574 model, which was around 27 kilometer, and when we switch over to a 12 kilometer model, this is deterministic of course, and you can see the blue dashed line, which actually day 3 forecast of T574, and that coincides with the black solid line, which is actually the scale of day 5 forecast by 12 kilometers. So what we can say is that we have gained a 2 days of lead time by enhancing the forecast from resolution from 27 to 12 kilometers. That's a good part of this story. Can you go to the next? Yeah, but not so good part of the story is this 2 event, which kind of became a benchmark for all the NWP forecasts across the globe. And you can see this is the famous time series over Kerala for 2018 and 2019, and you can see very clearly that these black lines are the observations, and these are from the GFS at different lead time, okay, and you can very clearly see that neither in 2019 or in 2018 the model could capture the observations very correctly. And I can argue, okay, day 1 it has captured to some extent, but by the time it goes to the day 5 and day 7, the model is drying up. The model is not able to cope up. So this is the situation in deterministic. The previous panel you showed this is statistics, but when you go to the individual cases, model is failing. Can you go to the next? Yeah, but in one of our paper, which is now under revision in weather and forecasting, we have seen that this Kerala event actually is a manifestation of a large-scale forcing. And what is that? And this is 2018 and 2019. You can see the wind speed anomaly. There is a very large-scale positive wind speed anomaly. Okay, this is significant. And this strong wind speed actually has brought. This is the moisture budget, and this is a tendency of precipitable water vapor, which is basically it's from ENI 1973. So just following these equations, what we find that the moisture convergence wherever it has happened due to this, okay, during the events, and that actually in phase was westward equatorial Rossby wave phase, okay. So wherever these two has coincided, we got this peak. So the fact of the matter is, the take home from this slide is that this event was not an isolated event. It has a large scale signature. It was a manifestation of large scale signature, but can you go to the next? Yes. So this is the performance of NCEP CFS extended range, and you can see in week 2, 3, 4, and so on, there was no signal for this, and this is NCWF extended range, And week 2 onwards, there was no signal. Can you go to the next? And this is ECMW. Here also you can see there was no signal for this event either. So the point is, even though statistically we can show it works very well, but for 2018 and 2019, the extended range could not capture it, even though there was a very large scale signature available. Can you go to the next? Yeah. So we tried to see if in a different window, and we plotted the probability, with respect to for all these models, GEFS, IFS. This is an ensemble, an income, NEPS. Okay, and this is done for climatology with 1 standard deviation. Actually, the event was 20 sigma. Okay, what has happened in Kerala, 20 standard deviations. But no model on Earth can capture 20 sigma system. So we decided, okay, let us test the model with climatology plus 1 standard deviation, 2 SD and 3 SD, where model stands. Forget 20 SD. So even if you take one standard deviation, which kind of comes in the 95th percentile, you can see the model is able to capture the probability of 70% for both the events. Okay, and when you go to the 2 SD, these two models still capturing that. Even 3 SD, 3 standard deviations income is producing. So the point is, there are ways to extract the meaning from the ensemble forecast, where one can still get some signal from for the extreme range. Can go to the next? Yeah. So this is a slide showed by Dr. Saha yesterday, and and this slide it has been discussed in IITM and in many platforms that the issue is week 3 and 4. Week 1 and 2 is good. Week 3 and 4 not so good. Whenever they do multi-physics MME, next slide. Or yeah, next, go to the next. Yeah, or they, if you take off GFS and just keep CFS, then also things are not improving to week 3. So question is, what's going wrong? What's happening? So can we get some idea from the daily scale, which can help us to understand something about week 3 and 4? And next, yeah. So you see, one common feature is that the extended range and this medium range both are under dispersive. What do we mean by under dispersive? Where all the ensemble members, they look similar to each other, but they don't look similar to observations. Take the example. Here is the example of last year August Mumbai rainfall. All the ensemble, see, they are looking very close to each other, but not close to the observation. Take another example. This is an extreme event over Bhopal. Again, all the ensembles are very close to each other, but they are not, close to observation. So this is what is known as under dispersive. So from the day 1, this model is under dispersive, and this is being carried on in week from days to weeks. So week 1, week 2, week 3, and week 4, no exception. So we have to correct it from the day 1 itself. Can you go to the next? Yeah, take this cyclone. We are doing excellent, but it is still under dispersive. You see here, all the members, they are similar to each other, but not close to observation. Okay, so this is the issue. We have to address it. There is no other way. There is no quick fix, and we have to solve it. Can you go to the next? Yeah. So this is for just for student. I tried to. This is from one slide I borrowed from ECMWF. So you see the ensemble members are very similar to each other, but away from the observation. This is what we call is under dispersive ensemble forecasting. Now, so one question is that Sahaji also mentioned yesterday that there are various ways. Now we are doing ensemble Kalman filter. They have had some other initial condition perturbation and so on. But what about the model uncertainty? How are we addressing it? Are we addressing it? Question is no, not so far. Can you go to the next? Yeah. So for this conference, we made some specific run with GFS and CFS for days and weeks. Next. Yeah. And when you please see here, so what we have plotted is the scatter plot of day 1 error along with the scatter plot of week. What you see is that when day 1 error is rather small, okay, the RMSE of week 1 is rather small. But when the day 1 error is growing, you see the RMSE of weekly also is growing. It is irrespective of GFS and CFS, okay. CFS is slightly, showing more error than GFS, but the message is same. Okay, can you go to the next? Yeah, so this is another example of what I was discussing about under dispersive. See, this is the spread and this is the error. If you remember that slide from ECMWF, so the error is more than the spread. So that's what is spoiling. That is in the day 1 to day 10. You go to week 1, week 2, week 3, week 4. The trend is same. So we have to correct it from here itself. Okay, next. Can you go to the next? Yeah, so this is one. So this is the schematic. Please look at it. So this is the initial conditions. Okay, we have set up part of initial condition. That's good. But what happened to this model? So all these part of initial condition, they look the same model. Okay, so the model uncertainty is not getting included. That's why one of the reason this forecast, okay, the uncertainty is not getting included from these model components, and so it remains under dispersive. One of the reasons. Can you go to the next? Yeah. So this is what actually ideally, again, it's from Saraj and Locke's slide. So this is when we do a model, model uncertainty, okay, and along with initial condition perturbations, then we can possibly get a better and do justice with the real ensemble forecasting. You go to the next. Yeah. So this is the thing what we are planning. Stochastically perturbed parameterization tendency. It's not being done so far. So and see what we will perturb is radiation, gravity wave, vertical mixing, convection, and cloud physics. All these components presently are going in a deterministic way, while the initial conditions is coming in a perturbed way. Okay. So this is a mismatch. Okay. Go to the next. Yeah, and this is another paradigm from Tim Palmer, where all the physics as it is discussed mentioned earlier, all physics are going in a very deterministic way, where in a scale separated way, which in practice, in reality, the scale cannot be separated. Okay, so this also needs to be taken care of through stochastic parameterization. Go to the next.
Dr.
Yeah.
Partha, sorry
Yes.
to interrupt. You have 1 more minute, 1 or 2 minutes.
Okay, so skip this. Can you skip it? Yeah. So this is one realizations by which we do the stochastic parameterization. I cannot go into the detail. Can I go to the next slide? Yeah. So yesterday Dr. Sahai was mentioning about the increasing the vertical level, and you see when we increase the vertical level, actually the Kerala rainfall event, the model is able to sustain the rainfall in day 3 or beyond. Okay, this is one way, and this is another way of improving the model forecast. Can you go to the next? Okay, next. Yeah, and this I mentioned because Professor Ravi was mentioning a hybrid parameterization. So here what we are planning is that, again, to break the deadlock of this convective this thing in extended as well as in the medium range, that you use the tendencies basically for temperature and moisture from a super parameterized model, and don't use the conventional parameterization, and train it for from the previous run, and then train it and get the trained tendencies to use it to the GCM. So this is one way which we are presently testing. Can we go to the next? Yeah, I don't know whether it will work. So why I showed it, there was a movie here. I showed because this AIML is good, but one issue what we are finding is AIML doesn't capture the variability very reasonably. It underestimates the standard deviations. Okay, that's what it is shown here. This is the SPCAM variance, and this is the machine learning based model variance. Okay, go to the next. Yeah, so I summarize. So my summary is like this, that ensemble forecast based on GFS at 12 kilometers of good skill, no doubt about it, in predicting extreme high impact and so on. But the forecast is under dispersive. And the daily scale error growth from ICs and physics modulate the weekly growth of error that we have seen. And models show a tendency to shift to a drier regime, that also we have seen. So these are the issues what we have seen. And how to resolve it, possible ways, is that improving the resolution of GFS, that we are presently working on that. We have shown that the vertical level, that also helps, but the measure I have underlined, SPPT and stochastic multi-cloud parameterization, could be helpful to improve the spread and RMSE. Unless we are able to improve the spread RMSE relations, week 3 and week 4 may have some still can show this issue. And this AIML, of course, we are believing that it can help to break through this cloud and convection uncertainty. I give the link for the TG, which Dr. Mitra has already said. So thank you very much. And before I end, let me thank Dr. Sahai, because he actually is a trendsetter. And there was no S2S. There was no S2S in IITM. I am here in the last 26 years. Short range forecast was there, seasonal forecast was there. So Sahaji, you have introduced something like T20 cricket, and you are the man of the match, you are man of the series. Okay, and my best wishes and gratitude to you for a very healthy, happy and retired life. Thank you.
Thank you, Partha.
Thank you, Dr. Partha, for such a nice presentation highlighting some of the issues with the forecast system and what are the possible solutions. Thank you, and maybe we'll take a few questions, and then is there any question? Okay, so I think there is no question. Thank you, Dr. Partha.
Thank you.
Over to you, Dr. Tyagi, for the announcement of the next presentation.
Thank you, Partha, for bringing out inadequacies of the present under-dispersive system for the extended range prediction from the modeling and need for improved parameterization physics of the models to bring in uncertainties of the model. I'm sure the initiatives taken by groups in IIT and other places will help. So we now move to the final presentation, which is again very, very application oriented from Dr. Kia Turkin from Singapore. She'll be speaking about using S2S predictions to improve disaster risk preparedness, example from the Southeast Asia. And my apologies if we're not pronouncing your name properly.
No worries at all. Thank you very much. Yes. Hi, everyone. I hope you can see my screen. Yes. Good. Yes, so hi, I'm Thea. I'm a senior research scientist at the Center for Climate Research Singapore in Singapore. And I also work in the ASEAN Specialized Meteorological Center, which is hosted by Meteorological Service Singapore. And big thank you to the organizers for inviting me here today. And I'm really pleased to share with some work we've been doing on using S2S predictions and disaster risk preparedness. So the example I'll be sharing today is from Southeast Asia based on some project I've been working on. So of course, also must thanks to my colleagues from the project from the ASMC, the ASEAN Specialized Meteorological Center, also the AHA Center, RIMES, and UNSCAP as well. So yes, this is talking about Southeast Asia, but I think there's a lot of lessons learned and points that are valid also for South Asia as well. So firstly, an introduction to Southeast Asia, the neighbor to South Asia. Here I'm just showing from a climate perspective, we sort of can split this up into two regions. We are affected by two monsoon seasons. Those areas in blue and green, has more rainfall during the southwest monsoon season, approximately June to August. And a lot of this is what we will term, and I'll use this term later on in the presentation, as mainland Southeast Asia. And then for the other, however, we also have other parts that are in this red color, and this is for regions that get more rainfall during the northeast monsoon, which is more December, February. And a lot of this, but not exclusively, is in the maritime continent. So this is the climate, but why we were working on disaster risk preparedness is that the region also experiences a lot of hydrometeorological related hazards. So this is captured in this figure here, which I took from the Asia Pacific Disaster Report in 2019. There's a lot of information going on here, but just to highlight those areas that are in the black boxes, these are areas that have a high exposure of economic stock to hydrometeorological hazards. And you can see there's parts of a lot of mainland Southeast Asia, also parts of the maritime continent, as well as South Asia as well. So S2S can help fill a critical information gap in disaster preparedness. And this generally requires a shift from more reactive approaches, which is a disaster happens and then you do something, to proactive, having to take action beforehand. So as I mentioned, this is part of the project we were working on, which was the S2S Southeast Asia pilot project, which the aim was to explore the usefulness of S2S products for disaster risk reduction at the regional level for Southeast Asia. And this is as part of the S2S Real-Time Pilot Initiative. So since February last year, we've been issuing regional outlooks to the AHA Center. And the AHA Center is our regional user that we're using in this project. So just a little bit more about the AHA Center. It stands for the ASEAN Coordinating Center on Humanitarian Assistance for Disaster Management. And they're an intergovernmental organization that helps to coordinate and facilitate disaster response in Southeast Asia. They coordinate through web-based platforms. They have disaster information management. They have a bunch of knowledge and outreach through reports and also training, as well as resource management for supply management. So for them, it would be very useful to have a heads up about possible disasters coming in the subseasonal times. Outlooks to them every 2 weeks. So when we started this project, we were looking at all the different products that we had and actually came up to 57 forecast plots and associated 60 skill plots for a subseasonal timescale. And this was using the ECMWF model. We used basically a Thursday run, and then we send it out this by Monday. And we look at a 3-week lead time. So in here in the brackets, beside the weeks, are the days from initialization, so days from the Thursday. And this is generally a Monday to Sunday, or it is Monday to Sunday. So we have all these plots, and these plots are looking at both rainfall and temperature, various parameters, anomalies, terciles, quintiles, probability of exceeding various percentiles. But we realized right at the beginning, this is way too much information just to give to the users. So although we send this to them, we also have a guidance document that we send every 2 weeks. So this is an example here on the right-hand side, and it highlights regions of increased chance of very heavy rainfall, extended dry conditions, extreme hot conditions, and extreme cold conditions at the regional level. So we have this little box on the right-hand side, and this is using the plots, using the scale plots and other information. We highlight the regions where we think there's an increased chance of extremes. And I'll just focus on heavy rainfall today. We also have approximately every 2 months discussions with AHA Center and as a team to see how the project's going and how we can further develop. Okay, so let's have some look at some preliminary results. The project still has a few more months to go until November. So this will be looking at reviewing the 22 outlooks we issued between the 28th of February and the 28th of December last year. So we're looking at the question, in the regional outlook, how many times did an outlook for an increased chance of very heavy rainfall result in one or more hydrometeorological hazardous events in the general location? So we're focusing on this sort of on the right-hand side, this box here, rather than the plots themselves. So this is using the forecast plus expert guidance. We'll split or we'll group them based on the 2 areas, the maritime continent and mainland Southeast Asia, and look at the various 3 weeks and look at for the number of hits, misses, and the false alarms. Just a quick example here. This is from the forecast that was issued on the 13th of July, looking at the week 3 forecast. So this is looking at the 90th percentile, which is one of the most things we use a lot for forecasting very heavy rainfall events. And this is showing the rock skill score for that week. And in this case, we're using, this is from the model from the 9th of July, but using for this assessing the skill is total of 9 start dates and to write on that date. Yep, and so you can see that areas that are yellow or orange or red, this has a rock score of above 0.7, which is pretty good skill. And this is mainly in the southern part of the region. For mainland Southeast Asia, the skill is very little to no skill. And this is actually something that's probably closer to the skill of South Asia as well, as we saw in Andrew Robertson's presentation yesterday and other talks as well. So this is the skill. And then this is the forecast probability here of exceeding the 90th percentile for rainfall. So using this plus other information, we came up with a small increase in chance for the week 3 in parts of Indonesia. So what actually happened? So this is the weekly disaster update produced by the AHA Center, and it's showing all the disasters as they were reported in that week, where that affected more than 100 people or more than 10 people perished. So if we look at this, we see in eastern Indonesia, there were actually 3 events related to flooding and landslides. So we would count this as one hit because it's one or more events in the general region. However, that we have a miss in Sumatra. This was not in forecast, as well as a miss in Myanmar as well. So in this, we would get 1 hit and 2 misses. So putting that in for the various weeks and combining with the other outlooks and splitting it based on those in the maritime continent and mainland Southeast Asia, you get this table here. First, focusing on the maritime continent in the table, you can see that if you sum up all the hits and misses, there are quite a number of sort of weeks that we had in areas that had one or more hazardous events. So it's over 100, which is quite a lot. Also, the number of hits and misses is somewhat similar. About 40 to 50% of the general locations with one or more hazardous events were forecasted ahead of time. Maybe this is not so high, but what is actually quite good is the relatively small number of false alarms. So about 75% or more in each of the weeks of the times are we forecasting an increased chance, does it result actually in one or more hydrometeorological hazardous events in the general location. We can also sum this up in the critical success index here in the bottom. So you can see that highest is for week 1, as you'd expect, but then still it doesn't drop too much week 2, week 3. For mainland Southeast Asia, remembering this is probably the one that's more similar to the results for South Asia, the skill is not quite as good. Firstly, there are fewer events in general, which maybe that's actually probably a good thing, but we're correctly predicting a lot fewer of them, so less than half what we're giving a heads up for. The number of false alarms is also relatively higher, although if you average across all the weeks, it is still less than the number of hits, which is, you want that to be very low. And then the critical success index here is, again, lower as we expect for mainland Southeast Asia. So what can we do to improve this? Well, very just briefly, we've been looking at using the IRI's next-gen approach, and we were comparing using like simple mean bias correction, which is what we use in the pilot project, with various model output statistics techniques. Just quickly showing an example here. This is there was flooding. This is in 2019 in the week of 7th of July here. And then this is just the forecast using the simple mean bias correction in the top row. And then this is using canonical correlation analysis, CCA, on the bottom row. And we find generally, I mean, this is just one case, but if you look at the skill scores and look at a bunch of cases, that actually this can help and really nice complement to the simple mean bias correction. And we heard lots of other nice potential machine learning techniques we could use yesterday as well. But just a point on this, for the pilot project itself, we're trying to look at Southeast Asia as a whole. And when we were doing this work using model output statistics, it didn't really improve anything if you were taking all of Southeast Asia. So I guess this is something to take away, is that for these techniques, what's going to work best will really depend on sort of the scale you're looking at and the region as well. It's also important we have our subseasonal predictions. So what actions can we take? So there's various actions. This is not an exhaustive list, definitely. But just to go through a few for monitoring, so you can undertake rapid assessments and continuous surveillance to identify areas expected to be hit. This is actually how AHA Center uses our information. Obviously, for hazard mitigation, there's various things you can take, such as releasing waters from dams. You can also activate institutional processes, such as to support financial risk management. And this is really good at the subseasonal timescale, because sometimes this takes a while to activate these things, especially if you're not doing it all the time. So to have that extra time is good. For early warning and evacuation, the examples here are not actually giving out early warnings or evacuating people. Rather, subseasonal information can be used to help prepare yourself. So you can provide media distributors with instructions on how to issue early warnings to the public, or for evacuation, you can confirm agreements with transport companies. All of these actions are, generally speaking, actions that are no regrets, so that even if the disaster doesn't happen, you can still get some benefit from it. It wasn't like a complete loss. Okay, so just to sum up, this is my final slide. Looking back at the project and using S2S predictions for disaster risk preparedness, some of the challenges of facing are reporting of disasters themselves. So this actually is somewhat similar to a comment earlier about the importance of observations. Talking with the people working in disaster risk reduction, to them the challenge is we don't know necessarily where all the disasters are occurring. This is a really big issue. And also when we try to assess the skill of our forecasts, actually, we don't necessarily know some of those false alarms. There could have actually been something occurring and it was not reported. There's also different reporting practices amongst the different countries as well. Also, a challenge is institutional connections. You can have a really great forecast, but if it's not getting to the right people, it's not very useful, right? And especially in the case for us, even the AHA Center is not the final user. They're sort of the regional intermediary, and they deal at the national level as well. So this is also something that's really important to take into consideration. And as also the skill is not necessarily so high for everywhere. And particularly, I think what we saw yesterday, there is skill in South Asia, but maybe it's not as high as in the maritime continent. But let's end on a positive note. So they're looking at the opportunities and benefits. There are demand from users for S2S products. And in particular, there's new practices emerging for forecast-based financing. And this is particularly relevant when you have a low number of false alarms. So even if you're missing a lot of the event, if you don't have a lot of false alarms, it still means that your product could be useful for forecast-based financing. And finally, just a reminder that there's actions that we can be taken at the S2S timescale that either won't at all or will be less effective at the seasonal weather timescales. So it's really important that along with trying to improve the weather forecast and seasonal forecast, we also look at S2S forecast as well. Thanks.
Thank you, Dr. Thea, for such a nice and interesting presentation on the applications of S2S towards disaster risk mitigation, specifically focusing on extreme rainfall and flood. Now it's open for questions. If anyone has any question. Okay, I cannot see any question. In that case, thank you, Dr. Thea, for such a nice presentation. And we are almost at the end of this session. I thank the organizers for inviting me to co-chair this session. I am really honored and humbled. And at the same time, I'd like to congratulate Dr. Sahai for such a brilliant career in this specific area, not only for the exceptional scientific contribution, but also for starting the S2S and bringing the making the climate services usable by the society. That's one of the major contribution, I believe, and I think this is, and I believe that even if you are superannuating, but your guidance is needed for the meteorological community of India. Thank you, and over to Dr. Tyagi for the final concluding remarks.
Thank you, Vimal, and well, I also join organizers for thanking them to give us opportunity to chair this wonderful session where we had a mix of 6 good presentations starting from the field observations, its importance in both research and application. We also had the operational perspective of use these products and the modeling part, seamless modeling at the NCMRWF, and also application of upscaling from daily to the subseasonal predictions being attempted at IITM. Also, the user perspectives we had from operational point of view in the last presentation. So a good mix of presentations from the eminent speakers. As coming to the Dr. Sahai, well, all of us have spoken. I had opportunity during my sabbatical in 1998. Today, people are talking about machine language, artificial intelligence, but Dr. Sai was working even at that time, and he was very forthcoming and helpful when I requested him to work on the thunderstorm forecasting using neural networks. So he's been visionary as far as I think science issues are concerned, which are application oriented. And from 2008, when I had opportunity to as a DGM to explore the possibility of extended range prediction, despite of many skepticals, and I think he took up this challenge. He was already working, and I am very happy to see that it has got operationalized. And he has created a team. He is not, see, apart from being an excellent scientist of his own standing, but he has created a team which will take this S2S work. He has taken it forward and he will continue to take it forward. So this is a big thing, that as a team building, you see, expertise, and his contribution is immense. Similarly, it's not only the science alone, but even the outreach, popularization of science as a part of the Indian Met Society. He has been vice president and chairman of Pune chapter, so he has worked a lot. So he is all-rounder in the true sense, visionary, team leader, and all-rounder. And I am sure he will continue to contribute. He has been helping not only the IITM scientists, but scientists from other universities and institutions also. So I wish him all the best, and will continue to be associated with him in whatever capacity he continues to work during his post-retirement. All the best, Dr. Sai. You had a wonderful innings, and second innings Indians normally play a much better role, so you will have a greater role to play in the second innings. Thank you. Jai Hind.
Thank you, sir. Thank you.
Thank you, Professor.
Work to the organizers.
Thank you, Professor Ajit Tyagi and Professor Subhamal Ghosh for kindly chairing the session. Now we'll break for 10 minutes and join again for session 4 at 11:20 IST, that is 5:50 UTC. Thank you.
So we shall meet at 11:20 again then.
Kindly switch on their camera to take a photograph.
Where is Subhamal?
Yeah.
Padmakar?
Where is Coach Subhamal Ghosh?
Players are not present, right?
Okay, thank you.
Thank you, sir. So we'll start our next session. In this session, we have with us Dr. A.K. Gupta from DSP and Dr. Rajagopal from former director NCMRWF. I request them to kindly proceed the session. Sir, please.
Okay, thank you very much. Very good morning to all the distinguished participants here, the speakers, and my co-chair, Dr. Ian Rajagopal. I think this is a kind of privilege that I have to co-chair this session with Dr. Rajagopal. I think the context of organizing such an important conference is cannot be overemphasized because of the fact that so much progress has been done in the short and medium range forecasting and the kind of advances that we have made in terms of model resolution, physical parameterization, and also the data assimilation system that we have today. Also, substantial progress in terms of seasonal prediction and that advantage that we have in tropical country of going for better predictability. Subseasonal forecast is in fact considered as the predictability desert, where we come between the west of short and medium range forecast and the west of seasonal forecast. But there is a greatest, in fact, demand from user for this kind of subseasonal forecast, and that is why the WWRP and WCRP rightly thought of launching this project of S2S in 2013. I think this conference is in that background, and of course with the background of I think this is to also give a farewell to our dear colleague Dr. A.K. Sahai, who is going to superannuate now in this month. I'm so happy to participate. I gave this opening remarks because this, maybe I may not be, continuing beyond 12:30. I have got another engagement, so I would like to I like my co-chair to take it forward. I would leave after 3 presentations. So I think we have in this session, as per list, 6 presentations. I'm told that each presentation should be for 15 minutes, followed by 5-minute discussion, and so that we will be able to finish the entire session in 2 hours. So 11:20 to 13:20, the total time available for this thing. And so I think I would, with this comments, I would invite my co-chair, Dr. Rajagopal, to give his opening remarks, and then we can start the presentation. Over to you, Dr. Rajagopal.
Yeah, thank you, Akhilesh. Good morning to you and Dr. Sahai and all participants. It's a very great event, which I'm happy that I'm able to co-chair with Dr. Akhilesh. Anyway, yeah, I have a lot of time at the end to talk because he has already said that he's leaving after 3 talks. So I think we'll not waste any more time. Let us go ahead with the first presentation. Akhilesh can announce.
Yeah, thank you. I think let's start with the first presentation by Dr. Giriraj Amarnath, IWMI, Sri Lanka. Dr. Giriraj Amarnath, please go ahead and present your presentation.
Now, Chair.
Yes, we can see. Yeah. We can see your presentation. Just make it full screen. Just make it full screen. That's all.
I thought it is now in full screen.
Yeah, now it is full screen. Okay, go ahead.
Thank you, Chair and Co-Chair, for giving this opportunity for this important event being organized by relevant institutions, including IITM and IMD, WMO, etc. And we also thank Dr. Sahai for inviting us for part of this session, and including our support receiving from IITM when it comes to data sharing to the International Water Management Institute. On that framework, this presentation is made the benefits of how S2S is being used in international water management in the working regions in both Asia and Africa. So I would just come with little more on the talking points here, while the experts in this session are very familiar on, I think you might have all spoken yesterday as well. I think we see there is a great progress in recent decades, at least in the last 5 to 10 years, on the advancement on S2S. And I think specifically in Indian region or the Indian large part of the South Asia, we see that the users are growing when it comes to using the seasonal forecast data. And I think critically, this data are going to be the future when it talks about climate information services, or we talk a lot about with the UN framework on the broader climate smart agriculture. I think this will transform into the system process among the user. It could be a private or a public sector. And the goal is of climate risk management. I was listening to the previous expert from Singapore on the AHA Center and the relevance of disaster risk management, how seasonal forecast is relevant. And again, I think it will a lot more shape if the reliability of forecast data is moving up to the scale that the data is required. We can talk more about building better resilient infrastructure, looking at the long-term prediction skills and how communities can play a big role in this. And I think equally, there are a lot of evidences are coming up when it comes to how this is more relevant to societal application. We have seen progress or the achievements in some of the bigger cyclone events and how this has been predicted. I think there are quite a good examples are there. We will speak couple of case studies that IMI is doing in the couple of years now. I think one of the things we can all talk where this S2S is again relevant in the regions where we talk about climate issues, whether it could be disasters or it could be related to vector-borne diseases, or it could be aspects where the arid regions where there is real need of forecast data are relevant. I think this map shows clearly the relevance of where the floods are highly frequent and happening. We see the regions in both South Asia, Southeast Asia, and large part of Africa. And the analysis came out from the WRA again points out that the South Asia region, including China and others, are having a lot more exposure when it comes to flood risk. So this gives a broad relevance that the problem statements are huge, and the potential of seasonal forecast is critically important, not just for the policy relevance, but also looking more into the farm level or the application that is looked at more from the societal issues. Now this is again a statistics coming from last year, where we talk about climate events are increasing. This is an average of over 400 plus events are reported, fatalities over 15,000, and 100 million people were affected. So this is again a very alarming situation for disaster management, or also the governments involved into the fiscal deficit is going to be quite challenging when you invest in adaptation. Equally, there is a exposure to the losses are critically important to address. And I think there is a role climate information services are critically important, like evacuating the people, keeping them in the safer places. I think a lot of things are going to happen, and it's happening already. Now, I just want to, within our institute framework, we see the relevance of climate information in risk identification, risk reduction, and risk transfer. This is where our strategy lies in the programs we work in across the regions wherever we do. But again, I see that when this particular forum is looking at this pillar of research, I think the elements of seasonal forecast or sub-seasonal forecast more relevant for early warning, for risk management, like lot of works might have been already presented. And importantly, I think from the farming community, advisory services are very important. And I think today we talk about mobile technology, which is playing a big role. Access to data is very important. While we see a tremendous growth in modeling system, I think sharing information, not just about relevance of weather, but how do you translate that into agrarian services related to information, and also being more multilingual so that this information can be used by the farmers. And I think equally the development partners like ADB or World Bank, increasingly investment in any of the larger program. If we talk about any multi-million-dollar project, this is the first component. Most donors are interested to focus on climate services, installation of hydromet stations to ensure that while you promote infrastructure resilience, we equally need to ensure early warning informations are there and they are embedded in their policy plans. I think this is very fundamental to begin understanding how we are looking at these pillar of data sets are critical. And the second aspect is that if we look at the policy relevance, we talk about how do you improve agriculture production and how do you improve rural livelihood. On the left side, if you look at early warning, early action, early finance, all they are very critical within South Asia and elsewhere. We promote this as an aware, as a framework for us. And what we do here is a monitoring system. And we work with ICR, Indian Council of Agriculture Research, on promoting the integration of contingency plans with early warning. CRIDA does a great job there. And again, providing agrometeorological advisories and importance of risk transfer through the agriculture insurance program. I think these are all very well fit, and a lot of evidences are happening in South Asia already, particularly in India. And I think the usefulness of this data is what we are not looking at data as such as a translation of information, but also data translate into action. So look at what is the water use efficiency of that. We go with the principle of less water, more crop, and then how water productivity can be improved. We are looking at irrigated systems. We have ongoing projects in a number of countries in Asia and Africa. Look at how this forecast data and the hazard data can be useful to identify areas of vulnerability and risk. And but not least, also areas are continuing to become in drought. We look at whether you can come with any drought proofing strategies, including the optimal use of groundwater, supplementary irrigation. So there are a lot of work where this climate information can be interpreted and used by the communities across the region we work. And then when we have climate information and the application that manages the risk, particularly in the agriculture or rural sector, then we look at how it can build resilience among the farming system and where we talk about the production. I think this is the core principles in which we work. And again, promoting awareness. These technologies are growing. The tools are quite upgrading quite fast. So it is important that the national partners get these technologies and tools, and they were able to interpret and adapt the usefulness of this knowledge. So that's the principles we work. And a couple of projects I just want to go as an example here. One is we have an ongoing project in both Assam and Orissa, what we call is a resilience. And basically the climate information is how we will be using in the CSA practices, climate smart agriculture, and how role of women participation in farm level decision making. So we work with MS Swaminathan Foundation and the agriculture universities in both the state. And important is to contextualize these CSA inputs at a local institution. So we have a farm school. There are a lot of state level governments are working in those two pilots. So what exactly we are doing there, this is one of the data we receive from IITM, ERPA's data, where we look at the next 4 weeks of forecast, what the situation looks like. And we also look at, in reference to the historical IMD data, how does the week are going to progress? Is there are any big challenges are going to come? And again, this is the last year data sets what we are presenting here. Once we understand, we do have access to short-term forecast. At the TESIL level, we are also providing this for the next 10 days. This is again coming from a commercial weather forecast data. But the usefulness of this, you provide more information that helps the farming system or particularly the village resource center, which is established currently in these districts, how they can make use of this data. And again, it's a question of validating this data, how reliable they are, how consistent we can use it for agro advisory services as well. So we started again establishing weather stations in those pilot villages. We are testing this data. And of course, there are certain errors in the data compared to forecast, but they are not quite alarming. I think it looks pretty good in terms of the short-term forecast data we are using. We haven't validated still the sub-seasonal forecast data, which is an ongoing process within us. And again, the usefulness of this data, we look at how this data will be useful for advisory message. I don't need to speak more on that. But again, it's not that it is forecast data and the advisories are available to the communities wherever we are looking at. So there might be a lot of limitations. So awareness and education is part of this project where we are working with a lot of extension agencies again there in those 2 states and delivering this data sets. Now, the other platform we are also using is the drought surveillance system or South Asia drought monitoring system. We use a lot of forecast data again coming from NOAA, GFS and other sub-seasonal forecasts. We provide the prediction skills of the drought likely areas that are going to happen. And not about maps, I think in India today we see a lot of knowledge products are up and running. And again, educating them and translating this information, farmers' participation of how they use and interpret this data. We hand over some of the tools there, so they collect the data and put it in their WhatsApp so that we don't need to be in the field with COVID challenges. Again, sharing these tools, promoting them, how digitally these data sets can be collected. And we are coming up with a dashboard where the farmers' data is also presented there. The knowledge products, whether it's a forecast or a satellite data from drought monitoring, all that we are putting together in our ongoing process with ICAR, Indian Council of Agriculture Research, and to see that what plans can be updated, what contingency measures to be done in the field. And again, this is currently looked at a taluk level, not at a farm scale. There are rooms for improvement again this platform. So again, the strength of climate information and gathering of knowledge coming from the field is critically important here. So I would also move the next case study in Afghanistan, where again the sub-seasonal forecast data is being used in Afghanistan. Digitally the data is provided by IITM, and we are streamlining this product for Afghanistan here. And again, the usefulness of this is what happens for the next 4 weeks. And again, there is a wider program is ongoing in Afghanistan, how you could make useful this data in the drought early warning committee. So the other aspect we are also focusing is often the data is not become handy for more users. So we have built a fully automated cloud-based system. It can be accessible in the mobile app as well. And the user can simply also change the language as well to the local. It is not publicly accessible at this point. We are waiting for the end user to officially launch this website. We will share with you at later point in time. It's not just only the forecast, but taking the forecast, what's the lessons you will be doing, and then you have a satellite data that monitors whether it's a SPI, whether it is a vegetation drought index, etc. As you can see in my next map, this is the next map where you can see once the forecast data is available, you are monitoring the vegetation condition, monitoring the 3-month SPI. We have our own composite drought index, look at the likely drought. And we have a statistical model that explains where the drought can be declared drought. So we have this framework is developed. So in a couple of weeks where the system gets automatically updated and relate with the seasonal forecast for the next 3 months or with the sub-seasonal forecast for the next 4 weeks, how the data can be used by those authorities and also making it useful. For example, the Ministry of Agriculture, Livestock and Irrigation officials in Afghanistan, the snow cover deficit as the precipitation forecast is shown to be low, and the snow deficit was significantly low this year. And they were able to place an order for fodder feeding to the livestock communities. So again, the data can be not just for looking at the broader application, it can be used in small way for how the livestock industries can benefit using this forecast data and the use of satellite data. Just I want to highlight this. And once we have all this data around the year, we are looking at a number of streamlined application of how this data is for early warning and the remote sensing data for drought declaration. and not just declaring the drought, but important is the early response triggering measures. So what we do is working with those line ministry, how do you activate response strategy plans, and we issue also the similar outlook like the previous presenter spoken about. And each month these outlooks are critically important for food security analysis. So in the interest of time, I will move to the last part of the efforts here. So again, the climate information services are critical when we take the lessons to Africa. We have been scaling a number of knowledge products and the usefulness of forecast data again. And as I said already, these products. And the last three was again in Sri Lanka, we are using the same mid-season, the sub-seasonal forecast data. I will show you an example of what we are doing there. But number of evidences are growing, and it's a question of how these accuracies can be validated in terms of the Z-score of reliability between the station data versus the forecast data coming up into the agencies they could validate. And I think in summary, I would say in future, the S2S is going to be emerging flood risk technologies can be used by this product. For example, we are talking about a lot of AI solution. Maybe there is a forecast, Ensemble forecast data already being developed under the WMO leadership. If all the regional Met agencies can release their forecast data, it might be available. Then we can come with quite a good Ensemble forecast skills, how reliable it is, how specific it is good for which Ensemble models. And I think a lot of rooms to improve there. And I think digitally, the power of AI can be used here quite significantly. And I think once we have those capability and accuracy of those products, then we can talk about applying that forecast data in the flood system, talk about how you can provide a flood alert. This is an ongoing project already by Google. And you can also prepare emergency map. I think the disaster management are critically happy about getting this data timely with the help of space agencies. And the last point is it's not about knowing the disaster where it happened. How do you transfer the risk? This is where how the knowledge information coming from climate data is critically important for risk financing instrument. So this is an example I got from the Global Flood Awareness System. They are issuing now a seasonal flood forecast for the next the month of until June. And again, this is using ECMF and other forecast data, the actual precipitation data, and a lot of interesting work is coming up there. So I think once the countries start sharing the hydrology data, sharing their Met data, we can talk about how we can improve the forecast models. And then I think it becomes more operational. This infrastructure doesn't need any establishment of a huge data repository or anything. It's a mobile based or a visualization app. You could start calibrating your model on fly online itself. So I think there are emerging solutions are happening there. And my last 2 point is that this is a very flagship product for us. How do you integrate climate information solutions in the bundled insurance product? So we provide access to specific seats, working with ICAR, working with CGR system like CIMET and other partners, providing a better seat, providing an agro advisory. If there are any risk has happened, we provide the claim through the insurance company. So this is a very ongoing efforts there. I just want to highlight here the data we are receiving from ERPAS and also from the short-term forecast data. We were providing the alert to Sri Lankan farmers here. And we have also alerted much well in advance that there is a likely chances of armyworm will damage your crops. So we could not really manage this extensive damage that has happened this season. But again, when you look at farmers, there are specific pesticides we can apply. And many of the farmers had a good success. So whoever didn't
can you please conclude? I think
this is my last slide. This is my last slide. Yeah. So I think there is a really importance of how advisory data sets are critically important. And if there are any risks that has happened beyond the risk management you adopted, the insurance will step in to provide the insurance payout to those farmers who had a crop damage. With that, my summary is that I think the forum and the subseasonal forecast has a great potential, not just for disaster risk management or understanding the weather shock, but also equally important in enhancing the farmers' agriculture production. And also, I think the modeling teams are evolving more and more. I think there is a clear need to develop more. Specific applications can be developed. And my last point, I think the forum like this promotes a lot of new knowledge, and the community of practice can be strengthened with more stakeholders. This will help us to build a lot more South-South learning in the forum what it is being organized today. So with that, I stop here. Thank you for this opportunity.
Thank you very much, Dr. Amarnath. This was a wonderful presentation. I think it emphasizes the need for South-South cooperation, especially in the region. And I think such kind of drought and flood forecasting at the seasonal and subseasonal level can be of great value to all of us. Is there any question? We can take one question. We have 1 minute left, so we can take one question, and otherwise we can go to the next presentation. Is there any question? Can you raise hand if you want to ask question? All right, so it looks like there are none. So let us thank Dr. Giriraj Amarnath for a wonderful presentation. We can have some question at the end when we find time. But for the moment, thank you very much, Dr. Giriraj. And then now go to the next presentation by Dr. R. Krishnan from IITM. Dr. Krishnan.
Thank you, chairs, Dr. Kilesh Gupta and Dr. Rajagopal for this opportunity, and also the organizers. And I would like to specially thank Dr. Sahai and also congratulate him for his outstanding contributions to S2S. So is my screen visible?
Yes, sir. We can see it. Just make it full screen.
Yeah. Yes, sir. Thank you. Yeah. So today I will be highlighting quickly what are some of the climate change projections over the monsoon region and what are the uncertainties. Hello. Yeah. What are the uncertainties and what are the key scientific issues? That is the plan of my talk. So the South Asian monsoon, it is very well known that it is a convectively coupled phenomena where the large scale circulation and the monsoon circulation and rainfall are very tightly coupled to each other. And there are multiple scales of interactions that are driving the monsoon through the entire season. They're also affected by external drivers like El Nino Southern Oscillation and also other external drivers, and it has its own internal dynamics. So this is a very simple conceptual picture. And so the fact that the monsoon circulation and precipitation are tightly coupled as early as this was old.
Your slides are not moving.
Oh, it's not moving?
Yeah, can you do one thing? You unshare and share again. Maybe it looks like some technical issue.
Okay, let me see. Okay, stop sharing. Again, I will share it.
Right.
Is it okay now?
We can see the slides. Kindly make it full screen, sir.
Yeah, it is full screen now.
No, sir, it is not there. Shall we share it from our side?
Okay, please. Yeah, I'll stop it now.
Okay.
Yeah, go to the next slide. Yeah, this is fine. This is good.
Yeah. Yeah. Can you go to the next slide? Yeah. This is a old paper by Krishnamurthy and Balme where they had already talked about this coupled system of the convection and the monsoon circulation, and they had reported how this coupled system can support quasi-biweekly oscillations. And now we have, with the TRIM data, we have information about we can estimate the latent heating, which is really on a very large scale, extending all the way up to Southeast Asia. And much of the heating happens well above the upper middle troposphere at 400 millibar or so, where there is a maximum. And this large scale heating is what drives the continental scale circulation. Next slide, please. Yeah, and this is a picture by Shige et al. Based on the TRIM data and the era. They looked at the boreal summer intraseasonal oscillations. Again, it shows how the convection precipitation which starts developing from the west coast of the Western Ghats, the west coast of India, and how the circulation during the active and break phases, they evolve hand in hand. And it's also tightly coupled to the water vapor in the lower and mid tropospheric levels. Next slide, please. So the question we are asking now, with climate change, with increasing global mean temperatures, which we know is largely because of human activities, addition of more GHG greenhouse gases in the atmosphere, the temperature has risen. What will happen to the monsoon? Can we go to the next slide, please? Yeah, now this is from the IPCC AR5 South Asian region. This is the climate change projections for different scenarios and also for the historical period. We can see that there is a lot which is shown, both temperature and as well as precipitation changes are shown. We can see that with increasing temperatures in the future, projected increases, precipitation is projected to increase in different scenarios. Of course, the RCP 8.5, which is the high-end scenario, has the maximum increase. But what is also intriguing is the large spread across the models. And with higher warming levels, the variability is also enhanced. So this high intermodal spread is something that's a source cause of concern. We go to the next slide, please. And when we look at the CMIP6, with this the recent set of experiments that have been finished, even the IITM ESM is also part of this. So for the future changes, we see monsoon is projected to be increase in the future, both for the SSP 245, which is a moderate scenario, and also the high-end scenario. But what is striking is the large spread across the models. So that is a major source of uncertainty. Of course, in the historical period, there has been a very slight decrease in the last 50 years, which has, of course, intra-annual variability and decadal scale variability, but some effect of non-GHG effects like the northern hemispheric aerosols and land use, land cover changes, that appears to have contributed to some slight decrease over South Asia. Next slide, please. And it's not just over South Asia. When we look at the global land monsoon domain, this is from again from the IPCC AR5, precipitation is projected to increase in future. There are increases in the evaporation. That's the most important thing. And so the precipitation increase over much of the global land region, monsoon region, is mostly because of the convergence of water vapor. This is the key point. But what is striking is there's a large spread across the models. And the other important point is the convergence due to the wind itself weakens in the future, but it is the moisture convergence that is leading to enhanced precipitation. So this is because we go to the next slide, please. So the moisture convergence is because of with warming temperatures due to the thermodynamic effect, or what is known as the Clausius-Clapeyron equation. For every 1 degree rise in temperature, water vapor increases by about 7%. And so in the future, with warming temperatures, there is more evaporation is going to lead to more water vapor content. And this is what is going to increase the water vapor convergence and precipitation. This is purely a thermodynamical effect. And next slide, please. So how about the circulation? This is one of the important aspects I wanted to stress in this talk. Although the precipitation due to moisture convergence is increasing, the circulation itself is projected to weaken. This is what most of the models are telling. And so this is from Held and Soden. Their argument is basically, if you say the precipitation is proportional to the water vapor convergence, and the rate of water vapor increase is much faster, what the models project, as I said, 7% per degree Kelvin, but precipitation enhancement is only very slight, about 1 to 2% per Kelvin. This would imply that the upward motions would decrease and the tropical circulation will weaken, something like 5% per Kelvin. So basically, the tropical circulation is projected to weaken. This is the Held and Soden hypothesis or paradigm. You go to the next slide, please. Yeah, but is it true that the the monsoon circulation will indeed weaken under global warming? In fact, we had done a high resolution experiment with a 35-kilometer high resolution model. So this is for the historical period, of course, from 1951 to 2005. So what we found was when we increased only the greenhouse gases, the monsoon circulation intensified as well as the precipitation intensified. So this is an exception among most of the CMIP models. Of course, when you have other experiments where we have the northern hemispheric aerosols and the land use changes, we do see a weakening in the precipitation and the circulation. But only with GHGs, this particular experiment showed an intensification of the circulation as well as precipitation. So the question is whether the monsoon circulation will indeed weaken under global warming. Next slide, please. So there are uncertainties in the future projections of monsoons. This we have to keep in mind. And monsoon circulation and precipitation are closely tied. We cannot separate them out, at least in the present day. So we have to understand what is happening in the future. Next slide, please. How do we do it? This is a picture of the famous ITCZ. Monsoons are associated with the northward movement of the ITCZ. Professor Gadgil, there are so many papers that have talked about it. So the key aspect is, can we understand the dynamics of the ITCZ? So next slide, please. So now there are new studies which are trying to look at the ITCZ, what will happen under global warming. So the ITCZ mean position on an annual mean is slightly to the north of the equator, around 6 degrees north. And basically the rising branch of the Hadley cell is located in the slightly to the north of the equator. And the atmosphere basically transports energy out of the ITCZ to the other hemisphere. And this explains the position of the ITCZ. Next slide, please. And subsequently, there was a paper by Schneider et al. They argue that the mean position of the ITCZ to the north of the equator occurs because of not just the atmospheric heat transport, also by the ocean heat transport, mostly in the cross-equatorial transport across the equator by the ocean, the Atlantic Ocean. And this is what maintains the northern hemispheric ITCZ to the north of the equator, because even it's not just the atmosphere alone, even in the ocean there are subtropical cells. So when you have the easterly trade winds on either hemispheres, you have transport of warm waters away from the equator by this ocean circulation, and this is what maintains the ITCZ to the north of the equator. This is an explanation. Next slide, please. So really, if you want to understand the ITCZ movements and the effect of climate change, we have to look at in a much larger scale, what are the global constraints of momentum and energy on the variability of the rainfall belt and the ITCZ. And this is a paper by Bayasuti et al. In 2019. And so that there are studies trying to look at the ITCZ from a zonal mean context of the tropical circulation. But when you try to look at regional monsoons or continental scale monsoons like the South Asian monsoon, there are differences. The zonal mean ITCZ, it deviates substantially from that. So we have to develop methodologies, approaches, how to explain the regional monsoon precipitation changes similar to that of the ITCZ. And yeah, and basically if you go look at this slide, they show an example for 2015 July precipitation from the GPM satellite. And so much of the precipitation is along the ITCZ, you can see. But within the monsoon regions, there are large considerable variations. And these are regions, this pink line is the region of heavy humidity, very high humidity levels. And there are substantial deviations within the monsoon regions compared to the ITCZ itself. So we need to understand these things. Go to the next slide, please. And a paper by Sabir Ali et al. Who had examined the CMIP-5 models, he had noted that compared the convective and stratiform precipitation from the CMIP-5 models, and now we have the TRIM satellite data where we have the estimates of these convective and stratiform rain. And in the observations over the summer monsoon region, the stratiform and convective rain over the Indian region is 50-50%. And however, most of the models, they simulate mostly convective rain and not the stratiform rain. Stratiform rain is underestimated. And due to overestimation of the convective rain, the vertical profiles of the temperature in the models are having major errors, especially in the above the middle and upper troposphere, and this can affect the stability and the circulation. Next slide, please. So these are from the atmosphere point of view, but when you come to there are also oceanic links, because the intraannual and decadal timescales, there are drivers like ENSO and IOD and also the PDO, where SST gradients can influence the monsoon and tropical precipitation. Next slide, please. And so this is from the IPCC AR5. They had looked at the Walker circulation, how it can change under climate change. Basically, the Walker circulation and the tropical Pacific SSTs are tightly coupled to each other through the Bjerknes feedback. It's a coupled process, so when you have strong easterly trades along the equator in the Pacific, you also have a strong east-west, west-to-east SST gradient, something like 5 to 6 degrees, and the charging of the Western Pacific, so there's higher heat content and convergence of moist air into that region. You have organized convection taking place in the Western Pacific, and which drives this large-scale Walker circulation. So during El Nino periods, when these trade winds weaken, the SST gradients also weaken, and the convection actually shifts eastward. And what studies have shown in the AR5 and other literature is, if the circulation, tropical circulation, is going to weaken under climate change, you tend to get an El Nino-like response. So the SST gradient will weaken. This is what has been hypothesized by many studies. Next slide, please. But recently there is a paper by Richard Seeger, Mark Kane, and et al. They have argued that that in fact the tropical Pacific zonal SST gradient has increased, strengthened. It has not weakened, as contrary to what the models are saying. So models are telling that with rising GHGs, west to east SST gradient will weaken in the Pacific. In reality, it has strengthened in recent decades as GHG concentration have risen sharply, and there's a stark discrepancy between models and observations. And they show that this problem, they used a simplified the Keynes-Zbiak model. They use the same dynamics to show that the erroneous warming in the state-of-the-art model is consequence of cold bias.
Just to remind you, you had just one more minute.
Yeah, next. Yeah, I'll be done, sir. Yeah, and also we have the same thing applies for the Indian Ocean region, where we have the Indian Ocean dipole, which can influence mean as well as very heavy precipitation in this region, largely involving the transport of water vapor from the Eastern Indian Ocean to the monsoon. Next slide, please. In fact, that we had a recent paper of the 2019, which was a very excessive monsoon, and it was an extreme positive IOD. This is by Satyaban Ratna et al. From IMD, who has joined now recently. So June 2019 was anomalously dry, but then by September 2019 it was anomalously wet, and the IOD had developed during this time. And so they argue that there is a low-level divergence of water vapor from the Eastern Equatorial Indian Ocean was very important in maintaining this increased enhancement of precipitation. So next slide. So in summary, what I want to say, this is my last slide. So even though when we say subseasonal variability, there are multiple scales involved when we are trying to look at the monsoon. It's a multi-scale interactive phenomena, and so we need to really understand how the coupling between the winds and the precipitation is going to respond in the future, not just the thermodynamic enhancement of the water vapor and associated precipitation increase, which may help in more extreme precipitation, but what is going to happen to the large scale circulation? How is convection going to organize? These are important points. So the prospects for improving S2S predictive capabilities in a changing climate, we need to reduce uncertainty in the projections. Some of the thoughts are develop a framework based on global energy constraints and regional monsoon complexities. We need to improve the representation of organized convection, latent heating, warm rain processes, orographic precipitation, mid-level circulation, also as aerosol and cloud interactions. Large-scale tropical SST gradients are fundamental in regulating the tropical and regional monsoon precipitation. All mean, variability and extremes, all of them, by altering regional heat and moisture sources and fluxes, convective activity and large-scale circulation. So we need to focus on process and predictive understanding by combining observations and models. There's a lot of ocean observing systems, And so we have to strengthen the data assimilation and strengthen the models. So this is my quick summary. Thank you. I think that's my last slide. Next slide, please. Thank you. Thanks a lot.
Thank you, Krishnan. I think very interesting presentation.
Yeah.
Is there any question from anybody? Can somebody raise the hand in case you want to? Yeah, Professor V.V. Rao.
Yeah, it's an excellent presentation by Dr. Krishnan. He has presented all the mainly problems. And so far, I have seen many of these presentations, science applications, not science research. And for the first time, probably, Dr. Krishnan presented what we should do about the science research. Still, there is not a good understanding about what is monsoon, how it is different from ITCZ and Hadley type of circulations, and this type of basic fundamental questions. If we don't solve, then we will not be able to advance much in the predictions. That's my comment. Thank you.
Thank you, Dr. Rao. Krishnan, do you want to respond?
Yeah, thank you, sir. Thank you very much. I fully understand. Yeah, that's important. Basic research has to go. At the same time, operational work has to also go. So we need a multi-pronged approach. Side by side, you need to have models, you need to have observations, you need to compare both observations, models, and improve the model prediction skill. And in parallel, the basic research of improving the monsoon processes should go in parallel. I think both are important.
Yeah, thank you, Krishnan. Krishnan, if you permit me to ask a question.
Yes, sir.
This is a very interesting result that you're showing that moisture convergence is likely to increase because of greater moisture holding capacity at the air and greater moisture availability. But then you are saying that circulation is likely to weaken.
Yeah.
And so in that case, because of you're saying that upward motion will decrease. So this gives me some contradiction in mind whether this will also, I mean, so far we have seen that extreme rainfalls have been increasing.
Yeah.
So do you think that in future, in the projected time, when you have less upward motion and circulations are weakening, so the extreme rainfall is going to decrease?
Yeah, that's a good question. This is something that has also bothered me. Extreme rainfall we can understand, but due to the very increase of moisture vapor, localized convection can be increased. But now all the models are showing that the large scale circulation will weaken. This is the CMIP models are showing, which is mostly because of the increase in the dry static stability of the atmosphere. But I think that the models are overdoing it. Probably there is some increase in the static stability due to warming in the upper layers. They're kind of exaggerating that. And so it is partly biases in the models, and we need to improve that. That is the problem. And as I told the Sabir Ali paper, they pointed out that the stratiform rain is underestimated in most of the models. So the vertical profile of temperature is going to be problematic. So we need to really fix the convection problem in the climate models. This is
very interesting, and thank you very much for presenting it to us. It's quite exciting, and I hope some good results will come in future to clarify these points. So thank you very much, Dr. Krishna.
Yeah, thank you, Dr. Akhilesh Gupta. Thank you, Dr. Rajagopal.
Really great presentation. So now we go to the next presentation by Dr. G. Srinivasan from the Rhines, Thailand. Dr. Srinivasan, over to you.
Thank you, Akhilesh and Rajgopal, and good morning, good afternoon, and good day to all of you joining from different places. It's a pleasure to join this very informative and excellently arranged, organized, and a lot of science content, as we have seen in Dr. Krishnan's presentation. It's been very good. I thank the organizers for giving me this opportunity. So my presentation is going to be more on application, and I'll just try to share my presentation. Organizers, there seems to be some problem. I'm not able to open the shared tray.
Okay, can you please send the PPT, sir? We didn't receive your PPT.
I have already sent the PPT. I think I even got a acknowledgement from Sushmita. Can you enable me to share?
Srinivasan, I think you first open that your presentation and then share. Then you will be able to share.
It is opened, Akhilesh. It is opened.
Sir, shall we share the PPT then?
Yeah. Do you have it now?
Yeah. Yes. It has gone.
Thank you. That will be great. Thank you. So sorry for that technical glitch, but hopefully it'll start in a minute. So what I'm going to share is briefly actually the field experience of one of the projects which was connected to S2S predictions, and also it is in some ways Dr. Sahai was responsible for it. So we used to meet in several occasions, and one of these occasions he said that we are not doing anything application oriented for Bihar, and this project actually focuses on Bihar. So it was at his instigation that we sort of embarked on this opportunity, which is a multi-institutional effort. So can I have the next slide, please? So yeah, this is going to be very simple in terms of sharing a project experience on using and exploring the S2S products for a particular pilot location. So this was a part of an international effort called the IRAP, the International Research and Applications Project, which is focused on integrating climate information and decision processes for regional climate resilience. And it was part of a multi-institutional effort, basically funded by NOAA and USAID. And the project was ran for about 5 years. It was targeting 2 different locations, very geographically different locations, the Caribbean region and India, and the latter little part was also done in Bangladesh. And actually, the project where we were, it's a multi-institutional effort, University of Arizona social scientists, the IRI, Andy Robertson and his team, and also the major contribution by IMD Pune and IMD offices, both headquarters office in New Delhi and also the office in Patna and RIMES, which is the institutions where I'm currently working. So the next slide, please. So in terms of the project objectives, it's basically the overarching objectives were to understand decision processes in which climate information is used, and also the institutional context, because it is an operational process. So the institutional context is very important, within which the information is provided, accessed, and implemented. So the steps, the basic steps we did were pretty much very obvious, like determine the vulnerabilities of the end users and work together with various agencies to produce this climate information which is required, and also see how we can provide decision support and improve through evaluation and building local capacities. And there is a nice conceptual illustration which I took from one of the papers by Mills et al., which sort of illustrates the various different components and institutions, basically. So, I mean, we have had very good presentations like today by Giriraj and also Thea talking about the AHA Center. And also yesterday, Raghu touched on some of the things which they did in Nashik. So basically, I mean, it's a conceptual level. There is farmer engagement. For example, if you talk about the farming community, which this project was focused on, and there are also various complicated factors when it plays out at the final user community levels. Is willingness to adopt, which is basically a lot of personal and individual aspects come into play, and the ability to adopt, which is what kind of resources and infrastructures are available so that the information provided can be acted on so that we can mitigate a certain risk situation. So this sort of engagement is what within this conceptual framework we were trying to explore in this project. So the next slide, please. So this gives the project location basically. Actually, the survey part started a long time ago, like in February 15 itself. But the main intervention which we were involved in actually started in March, actually February 2018, and it ran up to the next February 2019. So basically, I'm talking about 1 year of activities. And the location is the Bihar state, and within that there were pilot districts identified. 2 districts were in the east, that is East Champaran and Darbhanga, and 2 in the more slightly southern, relatively southern location, Jainabad and Nawada. So the brown ones are actually drought-prone districts, and the blue ones were actually flood-prone districts. So this was the pilot area where this project is targeted. And institutionally, as I said already, IMD, Delhi, Pune teams were involved. Dr. Sahai, Dr. Pai, Dr. Ghosh, Kripan Ghosh, Dr. Patnaik, all this big team was involved. And in the Patna office also, we had very good officers like Anand Shankar and Sandeep Kumar who were involved. So institutionally, there was a lot of connect. And besides IMD institutions, we also had the state agriculture universities, one in Pusa and the other one in Sabor, Bhagalpur. So these 2 institutes were connected, and also, research stations and Krishya Vigyan Kendras at a more, grassroots level. And also the final level, we had some NGOs also engaged who were conversant with those particular districts. So there was a lot of process which went into this setting up the flow of information within this project. So that in itself was a very, informative exercise and a learning exercise, which is critical. So yeah, next slide, please. Thank you. Yeah, in terms of interventions, the experimental design was that in all the 4 pilot districts, we had 4 sets of farmer groups. So one of the set received only text messages, and the other one received FFS, which I'll come to, which is the major intervention. And in addition to the farm field school, which is FFS, they also got the text messages. And there is a control group which didn't get anything. And there was another group, fourth group, which got only the farm field school training. So the main intervention is we held farm field school trainings. So this particular school, which is designed on the lines of a FAO integrated pest management practices system, where the learning is more experiential and it is targeted at the farmers. Basically, all these farmers, there was a lot of survey also done at different stages in the whole process of this field exercise. And the farmers are actually oriented for about 4 days in a sort of experiential learning process, where the local agriculture universities are involved, the meteorologists from the state meteorological department are involved, and others also. And they are basically made conversant with various terminologies and the forecast associated with seasonal to subseasonal forecasts, and also what kind of possible interventions are within their own particular local context. So this is a whole process which is called the farmers forecast application and risk management schools. So this was the major intervention. So there was a stage where we had the training of trainers, which actually trained the NGOs who were participating, and also the Krishi Vigyan Kendras who were connected to each of these districts, pilot districts. And those trained trainers were actually conducting the farmers field school for those groups which had exposure to the farmers field schools, like in the experimental design I explained. So this is the whole process, and there are some pictures of farmers participating. So the next slide, please. So within this process now set up, what was done was IRI in collaboration with IMD's extended range team as well as the Agromet team put together regularly operational forecasts every Thursday during the period June 7th to 27th September 2018. And these text messages were again further refined into outlooks and then shared with the state agriculture universities, which were basically also Agromet field units, which actually issued the bulletins in Hindi, the local language, which a sample is here. And this was taken by the NGOs and Krishi Vigyan Kendras and further sent to as text messages to farmers for all the three groups which I mentioned in the earlier design. And basically the forecasts were something like what we have heard in many presentations during the course of this seminar. And actually, it's a published paper by Andy Robertson et al., which came out in JGR in 2019. So some of the products were actually focused over the Bihar state, and they were week 1 and week 2 because the 3rd and 4th weeks had relatively lower skill at that point of time. So now we have, of course, more input products. So this was basically the flow of climate information up to the final level, where the farmers are, some of them are trained to take decisions and interpret these forecasts to their own local context. So with this setup, we ran it through the whole course of the monsoon season 2018. And then the next slide, I will share with you some of the results. So basically, farming decisions fell into these various categories, which are there in the bullet points on your left. So crop choices, choice of crop varieties, land percentage of the land cultivated to the land totally held, time of planting, transplanting, fertilizer use. So you have this range of options which were, these are again based on earlier consultations. These decisions were sort of aggregated into these broad categories. So when we look at the results of the end-line survey, what we see is that the group which got only text messages, they made 10% more changes in their decisions as compared to the control. And when we went to the group which had both farmers field school training as well as the text messages, they were able to make changed decisions during the course of that season, almost up to a 60% change as compared to the changes made by the control group. And the group which only got the farmers field school training also made sort of something perceivable and good percentage of change is about 41%. So this is based on the end-line surveys after the whole process of the season had played out. And of course, there was a preference in the drought-prone areas to use more climate information. And then, of course, there is a huge demand for more information, more tailored information, and so on. So now to the next slide, please. Yeah, this is my last. So in summary, some very informative learning points we got from that field exercise is climate information is strongly valued. And both these kind of experiential training as well as the text forecast made 2018, which was a unprecedented kind of dry year for the Bihar, many of the districts. So they shared experiences which they were able to use some of those information which they got to somewhat mitigate some of the risk situations which they were faced with. So this was based on our endline survey. And the more vulnerable farmers, of course, had very limited access and ability to use, and that's where probably a lot of work needs to be done in terms of capacity building and such trainings. And this whole thing needs to be scaled with use for agencies and so on. And there are complex barriers when you come to these kind of situations, land ownership, resources, social structures, and also traditions. So these are all factors which play out in the final, assimilation of climate information. Besides the, aspects which we are concerned as scientists, the accuracy and the skill and so on. So there are other factors which come into play at the last level. So improved climate knowledge and regular access, and also a lot of hand-holding from the Krishi Vigyan Kendras and local NGOs were found to be very good. So this needs to be replicated as much as possible. And also irrigation information interventions were something where they found the 2 weeks scale of information was very, it was rated as something to be very useful across all the groups. And also based on this, of course, IMD has been planning to evolve some of these systems further, and also work through organizations which are established at community level, like farmer producer organizations, and also align with grassroots agencies. So with that, this is what I wanted to share. My next slide is just to convey thanks, and also particularly appreciate the efforts of Dr. Sahai. And with his retirement, I hope that he will have more time to interact with RIME's activities and projects, not only within India, in the whole region. And he has been a great support to many of our activities on seasonal and sub-seasonal scale. Thank you very much. Over to you, Akhilesh.
Thank you, Srini, for a very interesting presentation. I may have some questions, but let me invite questions on the participant, if there are any. Okay, I don't see any hand up. So, Shini, I think this is like very, area, very, my favorite area of, because I work in this, how do you have, this matching completely, in this subseasonal scale, you find the scale and accuracy both these problems. Because, the scale at which we are going for the, including the information at farm level and the accuracy that we need, So first of all, this question comes in my mind: how effective are such advisories when we are struggling with both scale and accuracy? And the second question is related, of course, that Bihar is a unique case where you have large area under the rain-fed, and where the some of the critical decision, like say the sowing and all, become very important, because there's they don't have much, except the along the Gangas and other irrigation facility, you have so much area under the rain-fed. So I think these are two questions which are related, of course, and you may like to react to this.
Thank you, Akhilesh. Yeah, I'm sorry, I have some problem with the camera, so I'll just speak without the not in camera. So thanks for the indulgence. So very good questions, Akhilesh. I think one of the things is, you rightly said, accuracy, uncertainty, all this is going to be an issue which any user of climate information or weather information has to deal with. So this fact has to be clearly communicated. And also, many times as meteorologists and climate scientists, we aim to give the best accuracy and highest skill and so on. So which is very good and I think excellent and all that. But in the user context, climate and weather information is one component among the various complicated milieu of decision-making matrix. So when we take that whole thing in that spirit, then it's like, it's a risk information. It has a percentage skill attached with it that it will come through or not. So it is a balanced decision which you are empowering the farmers or any other community managing climate risk to take. So they have to be aware of the uncertainties and skill and how to use this information in use basically uncertain information for something which they can take a decision on to avoid risk. And here I think they have mentioned about the no regrets policy. So that is also very important that always the bias is towards taking some decisions which will anyway would be taken, but just shifting in time so that it doesn't have a major economic implications. So the farm field schools are aimed to empower the communities on this scheme. And about the irrigation aspects, definitely I think this is a very challenged area. So it's basically most of the farmers we interviewed in the exit, focused group discussions and surveys and so on, they mostly resort to groundwater pumping, so which is still available. And that is another thing, but the irrigation systems, they need to be more robust, but these are major infrastructural interventions. So most farmers, even the small marginal farmers which are part of this study, used neighbors and other support groups within their own villages to borrow pumps and provide substantial irrigation just to sustain the crops which they plan to cultivate. Thank you.
Thank you, Chini. Thank you so much for responding. Is there any question anybody wants to ask? Looks like none. So I think if you all permit me, I would like to leave now at this stage, and because I have another engagement. So let me, at the end, of my intervention here, congratulate Dr. Sahai and also IITM for this great contribution to the signal forecasting, and especially to Dr. Sahai for taking forward S2S project in a big way. And of course, the superannuation is something like inevitable. Everybody will have it today or tomorrow, and therefore this is a kind of transition from one phase to another. And so let's celebrate it. This transition is very important, and I'm sure Dr. Sahai will take it, as Srini said, that he will have more time, spare time to contribute to the science, and more freely and more, I would say, more aggressively that he can contribute. So I wish him a very professionally productive time. And I hope he will be able to do a much more contribution to the community as a whole. So all the best. Thank you very much for giving me this opportunity. I'm sorry I had to take leave of you, and thank you once again to all of you.
Thank you, Saints. Since Dr. Gupta will not be there for the meeting, so Dr. Ian find this session. Excuse me, sir. Before doing this session, we request Dr. Sahai and all the speakers and chairs kindly switch off their camera to picture.
Switch on.
Ready?
Thank you.
I'm done. Thank you.
Thank you so much. Thank you. Bye.
Can we go ahead now?
Yes, sir.
Okay. I will speak on a multi-model ensemble based for preparation of operational climate forecast outlook for South Asia. Dr. Pai, we have under 1 hour time, so if we can finish before 15 minutes, it will be very good. Thank you.
Yeah, I will try, sir. I will try. So you can stop me. So can you see my presentation?
No.
No?
Yes. Yes, sir, we can see.
Yes, sir, we can see.
Yeah, we can see you in your presentation.
Okay. Thank you. So I thank the organizers for giving me this opportunity, and I will be presenting on multimodal ensemble based method for the preparation of operational climate forecast outlook for South Asia. So this is the outline of my lecture presentation. First of all, I will discuss about South Asia Seasonal Climate Outlook Forum. As you know that IMD Pune as a regional climate center of South Asia is responsible to lead and prepare the South Asia Climate Outlook Forum, which is sponsored by WMO, supported by WMO. We have been working on the SASCOF activity since 2010. Dr. Ajit Tyagi Saab is there. He was one of the person who initiated this work. And since then, the methodology used for preparing regional seasonal forecast outlook has evolved into better and better. So I will be discussing on how the methodology have evolved since 2010 to till now. And then we are now proposing a new approach based on MME objective method for preparation of seasonal forecast to preparation of the outlook. And WMO also through its guidelines in 2019 is recommending instead of going to more of subjective method currently available in all the regional climate outlook forum. Around 20 regional climate outlook forums are there throughout the world. So they are recommending that we should make use of an objective method. So that is the main idea why MME is being proposed now. And we will also compare MME and SASCOF, operationally issued SASCOF forecast for the recent years, particularly some extreme rainfall years which I have selected, 2014 and 15, which were two consecutive deficient monsoon years, and 2019 and 20, which were above normal years. And finally, the conclusion. Now, you know that in the South Asia, under South Asia, we have got 9 countries. And when we started in 2010, many of the countries did not have a capacity to prepare and issue seasonal forecast. That is the main idea why WMO had recommended this type of regional climate outlook forum for the South Asia. So as I said, RCC Pune is the coordinating institution. Currently, as of now, we are also working with the UK Met Office and RIMES in supporting the SASCOF activity. So here I will be mainly concentrating on southwest monsoon rainfall, though we also provide forecast for OND season and winter season also. And for both of this season, we also prepare temperature forecast. But I will be here mainly the rainfall forecast during the southwest monsoon season will be concentrating. Now, as I said, first SASCOF was in 2010. First 3 SASCOF conducted in Pune, and thereafter was conducted in various parts of the South Asia every year, changing one country to the other. So far till 2017, 2020, we had 17 SARS-CoV sessions. In the first time in 2020, in addition to the forecast generally which we issue in April, the first forecast SARS-CoV is being issued. In last year, we also had an update in the month of June, mainly because we also got an opportunity to conduct these sessions through video conferencing because of the prevailing pandemic situation due to COVID-19. So that also helped us in preparing an update which was issued in June 2020. So going through the evolution, various methods that we used. Generally, we prepare the outlook based on prevailing large-scale global climatic patterns and seasonal forecast from both statistical and dynamical models. At least 50% of the forecast information derived are from the various dynamical models. Currently, that comes to up to around 80 to 90%. In the beginning, we were around using 50% of the information. And also, statistical models developed during the training workshop conducted by RCC Pune at various countries were being used actually. And we extensively use the CPT from the IRI to prepare the forecast based on observed as well as model data. And initially, in the first year in 2010, there was no forecast map was prepared. The forecast outlook was only text message. But thereafter, from 2011 onwards, we started preparing the forecast in this way. And forecast map depicted areas of most likely terrestrial categories, yellow, green, and blue shades over the region, and probability for each terrestrial category. So the areas were mainly depicted, by separating below normal, normal, above normal, etc. However, from the 2016, we started to issue grid point forecast at 1 by 1 latitude longitude spatial grid, particularly with the support of a lot of dynamical model information. And in each grid, it gave probability forecast derived from the synthesis of available information and expert assessment. It was derived from an initial set of gridded objective forecast and modified through a consensus building discussion of climate. And each of this grid provided the most probable category, terrestrial category, and also amount of probability that was given. And these are the various methods being used. Generally, in cases where models successfully product both the large-scale mode and teleconnection response, the direct model output was generally used since it has got a skill in that area. And countries also used hybrid methodology based on observed and model data to prepare the forecast. This is just an example of how we prepare using CPT model over entire South Asia. And also in 2020, how Sri Lanka prepared based on observed SST data, how they had prepared the forecast. And generally, they prepare also take help of other dynamical model output, and they suggest the forecast in that country. And then similarly, each of the country prepare their forecast and provide to RCC Pune. We blend all this forecast to prepare forecast, probability forecast in the entire region. Generally, forecasts are given at 1 by 1 over each country is prepared by respective NMHS, and they may use either single GCM or a MME of a few selected GCM. We provide generally GCM output to them to prepare this type of forecast, and maybe statistical model only, or based on hybrid where statistical plus GCM forecast are used to combine all such forecasts to prepare multi-model ensemble. And whatever NMHS given, we combine grid point forecast from each of the country into regional forecast. And this is just an example of how this forecast for 2020 was prepared. And once we get that, after blending all this forecast, the forecast map obtained is again further modified if necessary, based on to keep the spatial continuity in the grids close to inter-country boundaries, or to ensure the forecast map reflect the expected teleconnection pattern in line with the state of the climate drivers. So there generally happens some kind of subjective corrections happens on the map. So this is the final map that we had issued in April, or this is the way recently, in the recent years that we prepare. So this was prepared in April, as I said. In 2020, we had prepared, the first forecast was issued on 22nd April, first update. You can see that mostly in most of the areas we had predicted normal rainfall, except this part where it is a below normal and at the northernmost region. And Sri Lanka, southern part, including Sri Lanka and Maldives and southern part, this Andaman Nicobar Islands, etc., we had predicted above normal rainfall. However, in the updated forecast, you can see that in the similar way, we had issued an update on 8th June. Again, normal rainfall probability for most of the region. But however, this region had provided the above normal rainfall was predicted. And Myanmar, southern part of Myanmar, some parts, and the northern part of Andaman, we had predicted above normal, below normal. So this is just how the methodology was evolved in the preparation of SASCOF outlook so far. And this is the new method that we are proposed for implementing objective approach. And this is based on the guidance provided by WMO in 2019. This report is available in the WMO website. So generally what it is being done is, you have got several GPC model forecast from the WMO GPC, and you can select best models for each of the region after quality check. And then you, based on observational data from the region, you can bias correct and calibrate, and then to prepare grid point regional forecast for the South Asia. And then based on the local data and statistical downscale, you can prepare local forecast, for example, for the country like Nepal or Bhutan, or separately they can prepare their own forecast. And then finally, we can also prepare entire for South Asia in that way. Now for this we used 11 models. These are the list. I'm not going detail into that. These all the data are readily available in the IRI data library, and the data used was 82 to 2020 data. And resolution of 1 by 1. All the models were converted into 1 by 1 data. And this is how a weighted average method based on multiple regression, we had combined them to prepare the multiple model ensemble. But the coefficients, regression coefficients were calculated, however, using the SVD method, singular value decomposition. And for a long time there was proper climate data, rainfall data was missing for the region. So therefore, in 2020 we had introduced a merged data based on 1 by 1 rainfall data, daily rainfall data of IMD, along with the CHIRPS data over other region. We had combined to prepare a merged rainfall data for a long period from say from 51 to 2020 we had prepared this data. So we also 81 to 2020 a report also has been published and available in the RMC IMD Pune website. And based on this rainfall data, and as I said, 11 models, this is the CC rainfall pattern maps you can see for all the models. And this is country average rainfall forecast, skill of this MME, each of these models. You can see for RCC region together, and for each of the country for India. So you can see for example Nepal, most of the models shows some significant skill, but some of the countries like Afghanistan or Bangladesh, only some individual models shows the skill. For India also, a few models shows some significant skill. This is based on April IC, so that we can prepare the forecast and issue outlook in the end of April. And similarly, this is RMSE of each of these model. I'm not going detail into that. Just like CC, you can see that though there are some skill in many areas, particularly over central part and along the monsoon trough zone, relatively less skill is seen in most of the models. So this is for a country-based RMSE. And another, yeah.
Can you conclude quickly?
Yeah, so I will go quickly. So another index, skill we had used was index of agreement, and this is a model skill for index of agreement for each of the country. And this is for hindcast skill, that is for 82 to 2010, correlation, RMSE and index of agreement. You can see that compared to each of this model, the MME has got a better skill. And this is for RCC region together, performance for the period 82 to 2020. So you can see that some of the extreme events could be predicted based on MME. And based on this, just a comparison, this is the SASCO forecast in the April that we had issued, and realized terrestrial rainfall category and MME. So you can see that based on MME, there is a better skill. It could be 2020 could be predicted much better, much more closer, more reality than actually is the SASCO forecast which we had issued. And in the same way, we also had a prepared based on May IC to get an update for June. So this is the model skill for each of these 11 models. And for the individual country, I'm not going detail into that. And this is RMSE. And this is index of agreement, a special pattern, and for individual country. And this is the May skill for, a May IC skill for each special pattern, correlation, RMSE and index of agreement. You can see that compared to April, May had, in a more region, there was a better skill, though even with RMSE also, you can see that relatively less skill over monsoon trough zone. So this is one point which we had seen in most of the models. And this is performance for RCC region. And compared to June 2020 forecast and SASCO forecast, you can see that. And this is MME. You can see that it is the MME forecasts are much more closer to the observed terrestrial category than the operational SASCO forecast. And in the same way, as I said, we also had compare for 2014 similar forecast. So you can see that both SASCO forecast as well as MME was able to capture below normal rainfall over many of the region observed in the South Asia. And same was the case 2015. So both operational SASCO forecast as well as this objective MME forecast is able to capture this below normal rainfall over most parts of the region during both the consecutive 14 and the 50 drought years. And similar is the case with 19 when we had an above normal rainfall. So SASCO was issued in the April. We had a below normal in some of the region and normal in many parts. But you can see that MME in the issued in month of April could give you normal and above normal in many of the region similar to observed rainfall. So MME was performing much better than the SASCO forecast in the 2019. So my slide conclusion is that the process of preparing consensus regional rainfall forecast for South Asia under SASCO has evolved from 2010 when we had issued only the text format forecast to forecast map depicting areas of most likely terrestrial category during 11 to 15 to forecast map depicting grid-wise most likely terrestrial category as well as grid-wise probability from 2016 onwards. An objective method-based MME of 11 CGCM was developed to replace the existing method of preparing regional SASCO to make the process more objective. And we found that the objective method based on MME of this coupled models showed slightly better performance during recent years compared to the operational SASCO forecast. But the advantage is that MME is more objective way than some subjectivity which was involved in the operational forecast has been issued. However, I also want to add that we have to much more work on a selection of more models and also use other models output which are performing better. In recently we have got a model output from NCM, RWF, etc. So there is scope of further improving MME, but we have got now a tool to objectively prepare the outlook forecast. So this is being also one of the responsibility of RCC Pune to develop an objective method for providing outlook for South Asia. So which is just we have proposed. Thank you.
Thank you, Dr. Pai.
Yeah, I also just take this opportunity to wish Dr. Sahai, who also was head of this Office of Climate Research and Services, IMD Pune, during 17 and 18, and also was involved in the RCC and SASCOF activity, a very happy and contented retired life, and also a productive retirement life. Thank you.
Thank you, Doctor.
Are there any questions?
There are a couple of questions in chat box.
Okay, I just had one question to Dr. Pai. While going from, you went to 1 by 1 degree forecast, grid point forecast. So the skill has improved while going to that grid point forecast, or it was bad? How was what is your feeling?
Yeah, so actually your question is from a large region to 1 by 1? Yeah, so definitely, see, our main aim was that one is that you give more information when you give a 1 by 1. So countries, this become digitized data. Earlier, it was not a digitized data. It was just, drawing. You get output and delineating region, and large region you put under a tercile category below normal, as you have seen that yellow color in large region. But now you have got a gridded data, and that has got an application, where you can convert them into SPI or for other purpose, hydrology or agriculture purpose, it can be converted. And this objective which I am proposing is that it is a much more objective than earlier, where we had separate country and then blending and based on discussion some kind of improvement being done. So that is not here. This is totally objective. So it is a reproducible and can be, data can be preserved and can be also used for other applications for testing. So that is the main aim of developing this one, and the WMO is encouraging this type of method.
Okay, thank you.
Thank you.
Okay. So our next speaker is Dr. Bala from Incois on societal application of S2S prediction for ocean and coast.
Okay.
You have it full screen?
Yeah. Is it full screen now?
No.
Yeah, here it's full screen.
Okay,
I think it's visible now. Yeah. Thank you, Chair. And I'm very happy that today I can present in front of the Chair, who is also very much, I think, helpful for developing ocean forecasting system in Incois, and Dr. Sahai, who is also helping us actually going towards a seasonal prediction of ocean state. So at the onset, I wish Dr. Sahai all the best for his retired life, and as many speakers were telling, he will be more available for the collaborations and the discussions. And also thank Dr. Sahai for all the help and discussions earlier he has done for Incois and personal to me. So today's what I want to speak is a societal application of S2S prediction for the ocean and coast. As you know, I think the ocean state forecast, our ocean prediction systems itself is a very young stage, and this subseasonal-to-seasonal forecast of ocean is actually really in an infant stage. So my presentation mainly I'll be talking on the aspirations of the users and the what we derived from the user discussions, what is actually the applications they think actually for their activities at the ocean and coastal realm. As you know, I think we are going for the blue economy. So ocean is rich source of renewable energy, also used for tourism. Also, it's a main sink for the greenhouse gases. It's I think main engine for the climate change. Then also we have the fisheries, the maritime transport, the waste management. So I think ocean is very important. So I need not have to tell this one here. But meanwhile, we also have the a lot of challenges from the cyclones and the high waves, the oxygen minimum on ocean acidification, the depletion of fishery, coastal erosion, sea level rise, and tsunami. So importantly, this ocean prediction, especially the S2S prediction, is very important, mainly for the tapping the ocean as well as actually be protected from the ocean hazards. So in fact, we are going towards a kind of the blue economy concept where which hello.
Slide is not moving.
No.
No, sir.
It's moving now.
No, not yet. Can we share from our side?
Yeah, I think that will be better.
So you stop sharing.
Yeah, I'll stop sharing. Yeah, I stop sharing. Yeah. Okay, make it full screen, please. Yeah. Make it full screen, please.
You can see, sir?
I can see, but it's not in a full screen.
It is full screen, sir? Yes.
Okay, proceed. Okay, proceed. Yeah, but for me it is not full screen. Okay, proceed. Next slide. So as I told, it is next slide. So for the ocean for forecast and predictions are very much important for India because of its long coastline and also we are emerging blue economy maritime state. So we'll have more the industries are coming, and we are mainly on the area where affected with the cyclones as well as the high waves, and we have a lot of beach erosions along our coast. So it is very essential that we should have the predictions of ocean state, which is affecting our coast as well as the ocean users. Next, please. So if I think the below portion is not visible to me. Yeah. I'm seeing only I think 3 bars. I am not seeing the last bar.
But we can see 4 rows.
Yeah, I can see only. I know. Okay, what I'll do is I have my laptop here. I'll see here and start doing it. Yeah. So when we say about the S2S predictions, actually we have I think 4 areas we can think about. One is mainly the sea state and marine meteorological related, and the general circulation features, and the ecological forecast, and the marine water pollution. Next slide, please. So we have a number of users in the ocean area. It starts from the poor fishermen to the multi-million industries like oil industry and shipping industry. So each the user group, there is a separate usage of this information. Either it's a short-term forecast or a seasonal forecast. For example, the Incois is providing this ocean state forecast for 3 to 10 days forecast, but the fisherman, that is only the fisherman, that is artisanal fisherman, but there is a fisherman who is going to the sea, that is for them they require a seasonal forecast, that is actually is a monthly scale. If you can give, that is actually very essential for them. Like that, we have the disaster management authorities, port and harbors, maritime industries, and sailors and navigators, and the coastal population and tourism. For all the sectors, actually, the seasonal forecast is very important because sea is more chaotic than the land, the sea and land portions, and they have to design, or they have to plan their activities well before the things. So next please. So while going the S2S predictions, actually the marine sector to for a decision making, we require a complete set of forecast from the short term to long term predictions for the ocean and coast actually. So we have 1 to 3 days of short term forecast and 3 to 10 days of medium range forecast, which is going to ocean now. So this is very important for the issue warning and give the humanitarian aid and evacuation. And see, when we are going to this S2S weather influenced actions, that is S2S forecast, we can still identify 3 categories in the ocean sector, mainly for the early warnings, fishery and ecosystem service, and blue economy. For the disaster management authorities, we require for the preparedness of coastal flooding, storm and swell surges, high waves, financial risk, and the inform low scenario and community update. Like that, if you the coastal management authorities, we want the seasonal forecast of the coastal erosion. The fisheries, another sector actually where we require this information for the safety and the catch, and the ecological service for the habitat suitability and the marine heat waves. And the blue economy, we are looking for the 1 month to 3 months forecast on ocean state for planning the naval exercises, optimum ship routing, inland vessel limits, oil and the eddy forecast for the 3 months advance, the eddy forecast, and subsurface current forecast for the oil industries, and the tourism industries for the planning the activities, mainly the recreational activities. Next please. Definitely when it is actually when we can implement this forecast, the short term, medium range, seasonal forecast with impact based forecasting thing. So that is the ultimate, but a long way to go with that. So I will actually give a glimpse of the what are the short term forecasts we are giving from the Incois. It is mainly the storm surge, high wind wave alerts, high swell wave alerts, and the swell surge alert, and the Kondalkatu, that is actually very localized sea state and wind information for the coast of Tamil Nadu. So we have the threshold values for this, and we are also going to an impact-based system for all this short-term forecast. So the storm surge advisory we are actually giving in collaboration with IMD the most important thing is actually we have this inundation forecast where Incois is working. So the inundation, now we are forcing the models, which is the short-term forecast of the cyclones, its track and intensity. The issue here is actually we can give only one day before we can give the coastal authorities where the area is getting inundated. But if we can extend to the seasonal scale, definitely it will give a better advantage for the evacuation. This is the same case with the high wave warning where we are giving 3 to 7 days in the forecast, but the fishermen who are going to the sea, they require in at least the extended range, almost 1 month before, say they can plan their the long day or multi-day fishing activities at the sea. So it's the same case with this coastal areas like the Rameshwaram area, where they are actually depending upon our forecast for the operations, the fishing operations. So definitely if we get the forecast or kind of a guidance in the form of extended predictions. Yeah, next slide, please. Yeah, this is what I was talking about. This, I'm sorry, I think I'm seeing in my laptop and telling. So yeah, this next slide, please. Yeah, this I told about the high wave warning we are giving for the fishermen and the coastal industries. Next slide. Yeah, this is a Kondelkatu forecast or localized sea state information. Next slide. Yeah, another most important thing we are giving to entire the coastal states of coastal countries of the Indian Ocean is a swell surge forecast. That is the swells which is coming from the Southern Ocean that hit all the coastal areas, and there is a flash flooding. This is actually when the sea is very calm time only this kind of a swell surge happens. So here I think predictions, mainly this happens because of the sustainability of the winds in the southern ocean region, where this cutoff lows actually make this sustainability of wind and then enhance the fetch area and the duration of the sea for the swell formation. So once we get the seasonal forecasted wind parameters, we can also do the seasonal prediction of the waves. Next slide, please. So same case with the coastal erosion, because the as you know that during the onset of the southwest monsoon, there is much area of the western coastal area, especially Kerala, Karnataka and Maharashtra. There is a heavy erosion. So we are giving a 10 days forecast. Next, please. 10-day forecast of the this coastal erosion, which are the area get eroded during the onset of monsoon. But here the applicability of the seasonal forecast is very important, because there we can have the evacuation or kind of a shoreline protection mechanisms if we get the seasonal forecast or extended forecast of the waves as well wave related the coastal erosion. Next slide. So the combination of this in the sea, the combination of the short-term forecast, medium range forecast and subseasonal to seasonal forecast, actually we can set a decision support system where actually S2S forecast offer the opportunity for a disaster risk, that is DRR for the DRR managers. So decision making for disaster management that uses short-term to long-term range prediction. So we can have a system for ready, set to go, where the seasonal forecast can provide the ready monitoring information and early contingency plans, such pooling the infrastructure and the agencies. The subseasonal forecast provide the set early warning and alerting the agencies such as NDRF and Coast Guard, Navy, etc. And short-range weather forecast, as we are doing, actually, we are telling go and make the actions, actually, including evacuation and distribution of aid. So, this is the way we want to go in the ocean forecasting sector. Next, please. So we want to go. We are planning to go the extended prediction of all the parameters, especially and prioritize from the wave forecasting and the coastal erosion forecasting. Next slide, please. So this is some work we have done in collaboration with IMD, especially Dr. Sahai's group, where we have used the IMD ERF model forcing with our operational WWRP 3 model, and we have and this is actually based upon the BISO indexes. When we are forcing the model around 32 days, we have seen the active phase as well as the break phase. For we have seen that during the active phase or a break phase, the negative anomalies are seen. I think the waves are very low during this monsoon period, almost the 30 to 41 days. So this phase 1 to 4, what you are showing, seeing here, I think it is the break phase where we can use these windows for the marine operations and navigations. But for phase 5 to 8, it is very active phase, and it is a very phase where there is high wave activity and the erosional activities. So these are the time we have to plan for the coastal erosion preventive measures and other contingency measures. So this is just a beginning from Incois, and I am showing you one small example on that. So another important next slide. Another important area we want this seasonal prediction is fishery advisories. This fishery advisories we are providing using our the SST gradients, chlorophyll gradients, and identifying the habitat suitability. Next plate, next slide. So this is actually the area where you are seeing the thermal gradients, the meandering structures, and the eddy structure. These are the area there can be high fisheries. Now we are actually, our coastal fisheries is depleting. We are actually going beyond the ESET. We are identifying these structures or suitable areas for fish aggregation is very important, because we have to plan it a long time, 1 month or 2 months in advance, so we can actually go there and the fishermen can catch. So decision making for the better catch, the seasonal forecast of these thermal, these SST features and the subsurface features are very important for Incois. Next, please.
Bala, can you summarize?
Yes. Yes, I'll have another 2 minutes only. So what we want in a seasonal S2S forecast is actually the all ocean parameters to predict the habitat suitability and also the mariculture suitability. Even though I told this, it is very infant stage. Some areas like Australia, the seasonal predictions are used for actually identifying the mariculture site suitability and the impact of the SST, the temperature for the cage culture or some species like salmon. Next, please. So this is the same thing actually. I am looking for the algal bloom information service here also. If you can predict the ocean features for the habitat where the algal bloom, harmful algal bloom can occur, that is also great service for the coastal fishery as well as the coastal community. Next, please. So the same thing actually also applicable for the coral bleach. So we are using now the marine heat waves for the coral bleach alert, because some species, when they beyond a certain temperature threshold limit, it get bleach. So if you can get the seasonal forecast of this SSTs, definitely we can have a better advisories for the coral bleach. Next. So this is you can enter here, 1 or 2. This also very important for the fishery sector for the planning the optimal ship routing. So you know that what is happened in Suez the area during that there one ship is stuck there. Next, please. Also, see now the maritime agencies or shipping agencies have a blanket ban on this during the monsoon period. But when we can identify the break area, break windows where we can allow the shipping movement, that will be a great revenue for the port and harbors. Now we are giving a dynamic inland vessel limit forecast using this our models, but if you can make it seasonal thing, that will be great advantage for the blue economy stakeholders. Next, please. So this is see S2S predictions are very important for the oil sector, especially to prediction of the eddies and swells. This is actually the short-term forecast we are giving to the the oil industries. So there is a one incident just I will mention. Actually, there was two companies. One company actually they made their installation in an area, but they couldn't operate. But other company shipping this oil company almost 10 kilometer apart, they could do the operation. When they approached that, we could see that there is a big eddy and which is actually disturbing their all rig operation. So if we can, because this actually rig operations are very costly, I think it's billions of dollars. So if we can predict this the eddies as well as the swells, I think almost 1 month before or 3 months before, this very useful for the oil industries. Next, please. So this is the same case with the energy sector, mainly the offshore energy sector. Also, we can also predict this wind energy as well as the wave energy. It is actually going to add a lot to their revenue. Next, please. So overall, actually, we also made an impact of this our short-term forecast. So it is giving a lot of revenue for the Indian agencies. Actually, for example, the overall economic benefit of the short-term forecast, ocean forecast, would be in a cumulative benefit realized by Indian Navy, Indian Coast Guard, and value addition to oil and gas exploration, etc. As per our computation, it is actually 3.7 trillion. Definitely, if actually we can give extended predictions and season prediction, definitely this is actually the impact, economic impact will be much higher. Next, please.
Dr. Bala,
so
please.
This is next, please. Next, please. So concluding this, actually it is actually very important for early warning and the marine service for oceanic DR and fish service and support the blue economy stakeholder. Thank you very much.
Okay, thank you, Bala. I think we are running short of time. I think if any urgent question is there, we can take up all this. We'll go to the next talk. So there are no questions. The last speaker of the session is Dr. Vinu.
Yeah. I hope you are seeing my screen.
Seeing your screen. Yeah, now yes.
And are you hearing my voice?
Yeah, fine.
Okay, is it full screen?
Yeah.
Okay, thank you, Chair. Thank you, Rajagopal sir, for inviting for the talk. And I also say thanks to the organizers for giving me this great opportunity to present in this very important session. And also, thank you for the support from this extended range prediction group for this work possible by this time. And before beginning, I express my hearty congratulations to Dr. A.K. Sahai for his exemplary career and best wishes for his retired life. Wish him good health, and we look forward to you, sir, for your continued guidance in this extended range prediction research. Thank you. So today I'm going to give a talk about the application side of the extended range prediction ocean ensembles, perhaps a very less explored area so far in their product. And we are trying to develop few marine biogeochemistry deliverables from this. That is under its future perspective. That is my talk. I give thanks to Raju Mandal from their group who basically collaborating on this, and our groups here in IITM. So what actually the talk is about, this extended range prediction and analysis system in IITM is offering various services. We all are aware of it. We've been talking about this in the last yesterday and today in many talks. Basically, they look for the active break cycles of the Indian summer monsoon, and in the other seasons, they predict the extreme heat events, etc. So they monitor the extreme heat and flood events also using this product. And other human health related products are also being developed based on this extended range prediction systems. And agriculture related products, we have seen several applications from the several Southeast Asian and Asian countries today in several of the presentations. Then we are asking a question here: can we utilize the ocean ensembles to develop certain deliverables, which is a gray area so far nobody attempted. So looking at the potential applications, we thought, okay, we could bring up some biogeochemistry related deliverables which may be useful for the community. So what are the ocean ensembles they are offering the extended range prediction groups? There are 8 ensembles. They run with coupled models, two different configurations for each. For example, in CFS3, CFS V382 and V226 configuration. In both of these runs, they are using a common ocean resolutions, which is around 0.5 degree into 0.5 degree in the horizontal with 40 vertical levels, out of which 25 levels are in the upper to 50 meters. And they are initialized, to the best of my beliefs, is with the initial conditions developed at Incois, the physical initial conditions. And the forecast is done every Thursday, and the ensembles are available for further research to our group on the Thursday itself. So this is the snapshots of the sea surface temperature, the global in the native grid I am showing here. And they produce very valuable this 30-day forecast of these ocean conditions. This is the Indian Ocean snapshots of the current and SST I am showing here. So a few words about these ocean ensembles from the ERPAS group. The ocean ensembles produced by ERPAS system are, however, not well explored, as I said in the earlier. So there are potential applications for the ocean ensembles, and one such application is the development of marine ecosystem related variables. As a first attempt, we have come up with ocean biogeochemistry deliverables with model driven by ERPAS ocean ensemble. So that's the basic idea of this discussion. So what are the tools we are assembling for this achievement is that we have an ocean tracer transport model based biogeochemistry system working at IITM, used for several of the research in the past few years. So this is an offline model which required some input drivers, basically the currents, temperature, salinity, mixer layer parameters, wind surface forcings, momentum, mass, etc. So once you have this system, then we have a biogeochemistry embedded in it. So the schematic is showing how the biogeochemistry works. Once you have the carbon, which is the nutrients or the tracers, we trace using this physics, then we can incorporate certain biological and chemical sourcing terms to it. So this cartoon represents the simplistic representation how the carbon cycle works in the upper oceans. I'm not going to very detailed in it. This is biogeochemistry, people understand it better. So this system is working here for last few years, and this has been modified time to time by our internal research. And the details of this system can be found in some of these papers shown here. So what is the biogeochemistry module we use here? It is a simple phosphate restoration module. So which depends upon, we look at the World Ocean Atlas phosphate, and then we see how the model phosphate is deviating from it. The equivalent amount be converted into biological production. And then once you have a biological production, you have all the calculation for new production, export, sink, and etc. So we can calculate it based on the available module and already embedded in the model. So in addition, we also have modules to calculate the surface C2R CO2 fluxes and dissolved inorganic carbon and alkalinity freshwater fluxes. All are embedded and into this model. So coming to this extended range perspective, so so far we were using this model by providing input from reanalysis data, but today we are forcing this model from the IITM extended range ocean ensemble in the native grid, which is 720 into 410 into 40 levels. This is a native grid of IITM extended range ocean ensembles. So we basically take these variables, the velocities, UV, 3-dimensional, and temperature, salinity, also the hydrography, and the boundary layer height, which is the where within which the surface mixing is being calculated from the KPP parameterization, which is embedded in the model. And we also adapt the PME, precipitation minus evaporation fluxes, and wind stress, tau x, tau y, and sea surface height. We take, and QNet, also short wave, we take the net heat flux, and short wave we take. OPME repeated here, I'm sorry. And the vertical velocity we don't take directly from the extended range, because then it will come jump into a lot of mass conservation issues. So we rather calculate within our modeling system. So this is the basic structure of the model we adapted to convert this extended range ocean ensemble into biogeochemistry deliverables. So starting from the top left, you see that ocean ensemble available in NetCDF as daily averages for 32 days on every Thursday. And taking those variables UV, TS, and etc., as I already mentioned, even including the surface wind parameters for calculating their CA fluxes. So and we have an APU system, automated pre-processing unit, which actually converts all these NetCDF variable available in the native grid grid into a format which is familiar for the OTTM biogeochemistry runs. So this is automated, and this will convert all the data data into a required format for running the OTTM. So then now this data is fed into the OTTM biogeochemistry model, and for the 8 ensemble to run, it takes hardly less than 2 hours in our system. So with that, we will produce the daily outputs of the biogeochemistry for next 30 days. And that is basically the deliverables are the pH, the acidification of the entire ocean, and PCO to the surface, partial pressure of carbon dioxide in the surface ocean, which we use to calculate the CO2 fluxes. And oxygen, however, I show this yellow because it's not yet incorporated. It's a future development we are planning. And in addition, our idea is that in addition to the ocean ensemble that extended range is providing, we also have we can develop further the biogeochemistry changed parameterizations and develop into several other ensembles. There is a scope for that also. Then which will have a better spread from the mean. So then which may be useful for constraining the model more close to the reality in the future. So that's the future development we are planning. But however, I am going to present the results only from the left-hand side of the slide of the schematic. Now we have done a test case of OTTM ERPAS BGC for January, March of 2013, 14, 15, and 16, because these are the years we are getting input from the core group. So we are presenting here few initial outcome from the 24 February 2014 runs. So at first we have a task of validating our product, so which is very challenging because observations to validate the ocean biogeochemistry is really challenging. There's a huge data gap. Unlike atmosphere or ocean, we don't have much observation to validate. So there are certain challenges we are facing. So we are solving it, and also some are kept for solving in the future. So this is a simple example for the whole 2 runs I'm showing here. With the left-hand side, starting from the 17th February run, starting from the left, and it is giving the ensemble mean. And one of the runs from 24th February showing 8 ensemble spread for a particular point over the Bay of Bengal at 90 degree east and 15 degree north. The variable shown here is the PCO2. So from you are not seeing the slide moving?
No, there are no slides actually.
No slides. So far you haven't seen any slides.
No, so far we have seen, but now I think it is unshare or something.
Oops. Yeah. Are you seeing the slide now? It's calling experiments.
No, nothing is seen.
Oops, I'll share again. I think I got disconnected for some reason. Oops. How about now?
Coming, yes, yeah. We can see now.
Okay, you are seeing the slide called experiments.
Yes.
Okay, thank you. Yeah, I hope you saw my previous slides. I'm continuing from here. So this is the slide of the BGC output from Bay of Bengal for the year 2014 at 90 degree east and 15 degree north. There is a mooring we have
and the pH observations also available. So that's what we are targeting this point. So far, I haven't shown the observations here, but just to show how the ensemble mean and spread from the 24th February run, how it looks like. This is the variable shown here is PCO2. So interestingly, it is capturing a lot of spread around the mean. And I am not a forecaster, so I am also trying to learn how this spread is going to help me in coming up with a robust mean and variances. So that I am still doing the research, but it is giving some promises that the biogeochemistry system is responding to the variabilities in the ocean ensembles, which is simply physics. So that is very good that the ocean has the module is responding to the variabilities in the physics, so which may be a good point in future. Now, these are some snapshots for the week 1, week 2, week 3, and week 4 maps of the air-CO2 fluxes, and which is for a biogeochemistry person, it is quite familiar maps. You have emissions from the tropical eastern Pacific and sinks elsewhere in the north, mid-latitude north and southern ocean sinks, for example. The negative means sink, the positive means the source. So these all are coming reasonably well. And this is the ensemble variance. For example, I have 8 ensemble, and for each at the junction of each week, week 1, week 2, week 3, and week 4, I can look at how the ensembles are spreading from its mean. So looking at these spread ensemble variances, the first week you don't see the system spreading much. The ensembles are not spreading much from each other. But as the week develops from week 1 to week 2 to week 3, you see there are a lot of spreads, especially in the RC fluxes, focusing more on the southern hemisphere. And this could be due to we are looking at the February ensembles. If you look at the July ensemble, the spread of ensembles and its variance can be totally a different map. So we are now studying how this is happening, and are these happening due to the differences in the physics, or are they happening due to some variability in the biogeochemistry system itself? Still a topics under research. And this is the similar ensemble spread for the PCO2, the surface partial pressure of carbon dioxide, a very key variable which is required to calculate the RC flux and variabilities. So the week 1 spread is rather less, but week 2, the spread is more focused on between 0 to 40 degrees south, and the spread is rather weak in the Southern Ocean, a reason unknown to us so far, perhaps due to biases in the precipitation or SST. We are still doing research by what these ensemble variances are telling us. Now, if you go ahead, this is a surface ocean acidity, the pH values of the global ocean resolved from their extended range output. We can see very familiar pictures of more acidic value. More blue means more acidic, okay? The pH value list means more acidic. More red means more alkaline water. So more acidic condition you see in the eastern Pacific, in the equatorial region, and the Indian Ocean is having a mild acidic to alkaline condition. So this is a global map. And if I focus more on the Indian Ocean from this particular run of 24th February 2014, the left-hand side shows the mean pH maps produced by the AirPass BGC output. So you can see some interesting features like meandering structures. Those are very interesting because such frontal structures of acidity variations may be of good use in the future biogeochemistry community. So I'm not going to discuss more on that right now. And to the right-hand panel shows, however, the surface ocean acidity hotspots. While the hotspot is not retrieved in a proper manner, rather I am showing how the ensemble is spreading. This is a kind of an ensemble spread in the week 1 from out of this 8 ensemble. You see that there are areas where ensembles are spread very largely circled by a oval shape in the right hand side. So these can be correctly utilized to produce the spread or utilized to produce the hotspots of acidification, which we call it hypercapnia, which can be important for the fishery community. We are still doing research on that. Now, if you look at the pH gradients, which is what important, not the mean pH, but rather disturbing the ecosystem is the gradient in pH happening in a very short duration of time. If you look at the week 1, this is the gradient produced as the X gradient plus Y gradient and scaled by per degree. This is pH unit. You see that there's an interesting frontal structure in the pH gradient exhibits in the ocean, and that's actually can be captured by this extended range ocean products. And we have to verify this. This is the first thing. And if I look at the coastal areas, then you can see the pH gradients are quite interesting. This is for just a particular snapshot of end of week 1 from one of our attempts. And we are now investigating how the ecosystem variables are responding to such a sharp pH gradient. So who introducing this is the meanderings of the ocean circulation. The DIC and alkalinity, all the tracers are going to change according to the meandering, which can impart all SST as well, or temperature as well, which also can impart certain kind of pH gradients. So these are the, now if we come to the verification part, we are trying our best to verify this product. So what we, ocean community biochemistry observations are very meager. For example, in February 2014, this is the total ship track PCO2 available to me for verification. So what I have done is I have just taken the mean bias between the AirPass product as well as the observational ship-based PCO2. There are some confidences are there. For example, the regional patterns are captured reasonably well, but there are some areas where the errors are larger. Say, for example, in the Pacific, East Pacific near Japan, you see a larger error here. And another track traveling from the in the Pacific, that errors are rather less. So, and the North Atlantic also, the errors are rather less. So then we have to do more research to validate these products, which is going on now. Now, yesterday, this I taken as a screenshot from the Dr. Sahai's presentation. So Abhilash's paper has brought out the problems in the extended range products in the lead time scale. If you cross 20-day lead or ahead, you have a large cold bias in the SST. Well, this is a very bad news for a biochemistry person. Say, for example, the tendency of PCO2 in time is largely depends how the temperature evolves. So if you have a bias in temperature, say, for example, an SST of 1 degree centigrade error can cause plus or minus 10 microatmosphere error in PCO2 in tropical waters. So we need to deal with the bias, and they are correcting the bias for their forcing in the GFS. Perhaps I can depend on the bias corrected SST, which I can collaborate with them and improve. So what I'm trying to say is a bias in SST, a cooling bias can bring down the PCO2. This is a bad news for us, and this bias is persistent whether you take the Western Indian Ocean or the Eastern Indian Ocean as per this paper. Now, let me conclude. It's a very short presentation. So who all are the beneficiaries for such products? So to buy a survey, PCO2 or C2 or CO2 flux forecast for 30 days may not be beneficial to any particular community, but acidification, in fact, and its gradient can be beneficial for the fishery applications. We are working on it. We have people, we are looking at those aspects. And acidification data is also useful for sonar communication. This is very interesting because the sound navigation and ranging depends upon how much free H+ ions present in the water. So I have contacted the Navy people. They are very happy that such products are coming. So for Navy operations, they don't have such a real-time pH data or its gradient in the ocean, open ocean, for their sonar communication. So this is a very important branch we can bring up, and then we can utilize our product as well. Oxygen, on the other hand, we are not producing right now. An extended module to IITM may attract more beneficiaries such as fishery community, which are under development. So my conclusion is that the ocean ensembles so far produced by this group is very useful for a biochemistry deliverable developments, and we are working on it. And with the support from their group, I think we can bring very meaningful output in the future. So saying this, I'm thanking the organizers again for giving me this opportunity. Thank you.
Any questions? If there are no questions, I would like to thank all the 6 people for delivering the talks. There are some issues with technical since things got right. 4 talks were on ER applications. One was on monsoon variability by Dr. Dr. Pai presented the multiple techniques for climate prediction system. And I don't want to summarize too much. We're already running short of time, but I would like to note that I have been promoting this product to various customers, and a lot of people are using it. It's a good site. So the ERF products are getting various applications. It's a good thing to note. And finally, I would like to thank the organizers and Dr. Sahai for giving me an opportunity to share this session. And I congratulate and wish best wishes to Dr. Sahai for a more productive career after retirement. Thank you.
Thank you, Dr. Ian Rajagopal and Dr. A.K. Gupta for chairing this session. I also thank all the speaker participants. With this, the end of tomorrow we'll start our last scientific session at 2 p.m. IST, that is 8:30 UTC. So see you all tomorrow. Thank you.
So we are going offline now. We'll meet tomorrow at 2 p.m. Indian Standard Time.